well, will that work? I guess I have to check it, right? So. This. Yeah, so my old phone still has the old app. And it seems to be. There, I think it's kind of okay. I tightened this a bit more even. I'll see if I have it right. Right, the helmet. My kid's helmet. Though it's not extremely ugly. It's for my kid's role. I don't know. Probably you shouldn't have one that's over a certain age or something, right? I don't know. Anyway, I turned off my Wi-Fi before I started now, so we shouldn't get a disconnect when I exit the house, which I did last time. So now I actually have an app for actually checking. Let's see. There, so I can click a start a bit in here. So this one, it's kind of moved a bit. So that's annoying. Well, we'll see. So I have this other holder holding my other phone.
Let's see if TTS does work.
It's too much space. So I might just skip it. I guess that phone could still be in my pocket, right? Though it will show me like how far we've gone. I'm clicking start on it now. So at least I know what. Unfortunately, it shows like average speed, and I would prefer to see like the current speed, right? That would be more interesting. So there's actually a white place here. I realized cars stop instead of me waiting for them. So maybe that way is quicker. Yeah, and my phone is angled already. So we'll see. Right, so this time you should be able to see this part of the road. Because it was just nothing last stream. Yeah, it still messes with it. My phone is rotated, I think.
Are you on any bike?
Right, wrong side. So they switch sides. Or is it like always closer to the road, maybe? That's probably it. So far we have 15.7 medium velocity kilometers per hour. And it's about half a kilometer. So kind of fun too. We've also been biking for 2 minutes. That's why I brought that, you know, an app. But I was really going for something that could find a good way to bike. You know, like ways for cars. So I'll look for that later. Oh my god. So it was cigarette smoke all over the place.
det tillåts fan to glide down.
So 17 kilometers medium. We'll see what it becomes. And we'll see what road we select, right? So there's a car behind me. Stop. That's always annoying. Should have been on the road. But I guess you're not supposed to when there's an actual bike road, right? But I wouldn't have had to stop then. So when we get home, right, let me show sweat. I should have called map so I can hear TTS. If anyone says anything. And smart as I am, I didn't even put my headphones in. You read some though. So I'm curious if I would hear this. Yes, we'll see. So I really want this to test then. Do I? I'm trying to look at the timer, but I don't know. It's just too bright light, I guess. I'd like to see the current speed, not the medium. Average speed. 17.4 now, but what do we currently? What's our current speed? You know, that would be much more interesting. This is why the average speed is kind of boring, right? It's rotated again. Yeah, I'll have to remove the other thing there. I think I can see the GPS on, though it's kind of wrong angle and kind of dark. So 2.5 kilometers, 8:45 in time. So that's totally new to me, to see information. But I would prefer a map on, oh, you can go this way. That's what I was really looking for, but I spent like 2 minutes. Also, should I use this wide angle? Or should I do the more? Well, I guess the phone messing up is not as bad when it's wide. Cars. There's a car where I usually drive now. No, it's behind. So you can both go straight and down here. Both are like bad. Right, there's one of these here too. Cars are pleased with the stuff from these. Guess I should use those? Well, I don't think it's useful. I think actually that car, if it had been a bit worse in like timing, I would have had to stop anyway. It's better to go straight ahead, right? More people in front of the hedges. We should be right. At least we caught.
GTL Learning.
Hello. It's like up here and then go down. And then we have like a 90-degree turn, so I'm not sure which is the most efficient way. If I go straight ahead, I get a bit of uphill, then I get red light though. Then I don't get any red lights if I go right, which is a 90 degree. Feels like bad inefficiency to do a lot of 90 degree turns right. Shouldn't be the shortest path. So well, there's no car there. We're going underneath E4. It is E4. Europe Highway 4 in a bit. Yeah, let's slow down a bit. So this is boring to this road. This is not fun. This is straight. Slight uphill. I think I prefer the other one. It's steep uphill, and then it's downhill. And there are turns. And the red light though, I guess. I'll have to compare them. There's the road. I got insect in my eye. Whew. So what is this? The fourth time, or is it the fifth time I'm back to work? Exploring new ways and a lot of insects here. So this is definitely the most, well, one of the most boring ways. And if we go quicker, there could be people walking on the road, you know. So we're at the maximum gear. No more gears. Now it would be nice to see like the speed, even the screen shut off on that phone, so let's see if I can turn it back on. Code. Yeah. So there's golf here. I'm not much into that, but some people are. We have two. One on the side of this road, ahead of me, and one on the other side. So one's just behind my house. So I guess it would be good if I liked it. Funny to see a long car with yellow balls. I thought so. It moved a bit, right? So 5.23 kilometers. Yeah, let's take a more fun road. Straight ahead with just this road is where I live, you know? Let's go right. So going just for more than a kilometer on the same road. Because of the crossing roads, I guess. So I'm thinking we'll take the forest way. So I'll go further than I need, right? But let's do it the fun way. So I actually was biking with my 14-year-old on my hobby yesterday. I was going to actually rest during the weekend, but he just learned to bike. And Saturday I got him, well, not a new bike, but my dad's old bike. And it has the same gears as this one, which he's been using. And it was the perfect size for him, so that was great. So we usually go home up this way. Then we're going down instead. Now we're going back to work. So we need to get back down to the water. I can turn here. The more green, the better. Yes, if I was going the shortest way home, I would go left. I'm going actually to the right. Oh, I just noticed my seat has changed angles, and I heard it now, how it just changed. So I'll have to do something about that. Oh, it moved more. So annoying. So it's actually angled. I lean forward quite a bit. So when it's flat, the saddle, it's not comfy at all. So this is kind of a big road. No cars. Trying to keep the camera straight. Yeah, so I'm actually going to find a new way to go to work. Today was a bit late, so just went the normal way. So now, this is much more nice. we have some swamp babies now. I saw that the last time. Yes, we're just close to the trains for Arlanda here between Arlanda and Stockholm. And there's our airplane here. No birds on the wing. My other phone is closed down again, so I can't really see anything. But we're almost home. The other way. The wrong way. So now. There. So it's been 8 kilometers. Now. It's actually like 6.5 if you go the straight way. There's actually a sheep and stuff there too. So if we don't come right there instead, and cows and stuff. And sometimes they have strawberry cooking. But I don't know, I haven't seen anything like you see something about the saddle. It's horrible. I try to like, it's not supposed to move, I guess, but I want it to move. So I put it like in the bend of the metal fastener things. Right. So yeah, my legs are actually a bit tired. I'm trying to switch cameras there. So I have this thing on here. Let's see. This thing, and it was too close, so it bent the angle there. And this one I had angled this way, and I was going to back this. It's kind of annoying. I don't like these bowls. Actually, it leaks here. So I just put my back. So, what does it look like on my kid's helmet? And if these have an age of it, this is definitely more than 10 years at least. Oh. Hello! So this is a phone that's usually tightly right. Okay, let's try it. Actually, let's remove this from here. That's a warm phone. So let's say bike from work. There. Oh, you can put like images. Type of ride. Commute, yeah. So, and the annoying thing with this app is that, can you see now there? So there's the bottom of the button at the bottom is discard activity, and saves a tiny thing up here. Which, how easy is it to press the big button at the bottom instead by mistake? Yes, there's lots of planes. Lots of planes here. My mom always notices when she's here. So, let's see. Yeah, so I've got these tires still, so I haven't used these, like, ever. But the area here, they had, you could get, like, free driving to work in the winter stuff. So, I got these for free, and I also got, like, where is it? Yeah, I put it in the drawer here. Here, probably. Yeah, so we got this kit too, to fix tires and tools and everything. So let me switch that back. see if my kids have eaten lunch. And I assume that my oldest is still asleep because he fell asleep when I went to work, and it was like 9, and it's just 13 now. So I shouldn't have had my jacket on. So just sitting there.
DJ Chateau says, "Get translated from Turkish."
Hello, I didn't hear what it said though. So I'm just about to get started with the cybersecurity stuff. So just back from work. Why not, you know? You're still going there. Let's leave that one here. We need this phone. There. And I want my water. Right. So this one got wet in the rain yesterday, and I didn't have it on the bike now. I don't think I noticed. I noticed the angle though changing. So let's see here. I need some lunch, and then we'll get started. So I'm going to do, let's see if this angle is good. This is like
Influx says, "This is so cool seeing some CS stuff on Twitch."
Oh,
You already know what room you will do.
yeah, we're going to do buffer overflow rooms. Hopefully more than one, we'll see. Because there was a, hopefully one, because I wanted lots of information and lots of details, you know. Let's see if I can leave the phone with a move here. I'll just fall. Maybe like that. Yeah, the other phone's back underneath.
Sound great. Are you working in CS or currently start learning?
So I just started looking for work in this area, and I'm currently working with other stuff. I was actually working now at an electronics company as a consultant. So it's very close. It's just 6 kilometers or 6.5 with a bike. Oh. So the problem only, I'm kind of sweaty now. So Friday I actually took a shower before I started, but I'm going to just continue now. I just put some water in my face and hair, so it'll pass. Let's just get some food. All right, I have Thai food leftovers. I don't know if I can eat all of this. We'll see. And this is so hot. Let's refill my water. I'll need it. So me biking for work. It's like a long countdown to the stream, right? So I put that on 2 minutes. Let's actually go upstairs. I can go down and get this. So, water. I'm also going to ask my kid if he ate something. But I'll leave you there, over there, first. Because he doesn't want to be on stream, so. Also, my lights are not on and stuff. So. And it's a bit of a mess in here. So, I'm turning my screens on, turning my audio on, because I muted, you know, so, since this is a computer I stream to, when I'm not...
DJ Chateau says, "Be sure to regenerate your VPN files as soon as you can. Your HTTP and THM VPN files are available to the internet."
Yeah, I saw that they had new files on TryHackMe. But we'll not do it right now. Let's just, I'm going to switch over to the PC here from the phone.
You publish them in your Obsidian repo.
My VPN keys? No, I don't think so. Did I? That would be kind of stupid. So.
Influx says. XD. Translated from Spanish.
Yeah, so there, now you have audio again too. That might be nice, right? So I heard my food beep downstairs. I'm going to turn off the TPS on my phone. And I'm going to make sure you can see me too, right? I'm starting my app for connecting to my lights. So let's see. Alright, no TTS. Alright, desktop audio is off. Yeah, so I realized why the audio was off last time. Let's see here. My audio is muted.
Aiden says,
too.
Good
So
evening,
there.
smile, smile.
Good evening. Welcome back. And I'm looking at the camera, though it's not on yet. So now.
What will you be working on today?
So let's see. Was it actually on? We'll see. I have to change a variable too in my streamer bot. So we will do buffer overflow stuff. So if I go to my right screen and left screen in 2 seconds. No, it's not connected yet. So I'll just open streamer bot and we're going to change the variable there for is remote to false.
Have you gotten much further with Windows VM and WSL?
I did Google a lot, and I did get the other one that had like nested virtualization running, but not mine. So let's see now. If I switch screens now, we should get the camera back. Yeah, so, automatically. So I need to go check with my kid, and let's also hop over here, right? There. So I'm kind of sure I don't have any VPN keys in my repo anyway. Though I did share. Now let's see. I could have, when I moved my files from this machine to, I moved them to that directory. So I could have actually. Let's see. I don't think they're very like, who want to hop into mine and do my. I guess someone who's not. I mean, I don't pay for Hack the Box, so. But TryHackMe.
Influx says,
but you
can't
still
find
would have to
them
log
in the
in as
last
me.
commit.
What did you say? Yeah. Oh, let's. I'll just look at chat. Let's see. Yeah. So, but they were in an old one there then. Maybe. Okay. Yeah. Because I temporarily added them to that directory, my like cybersecurity files for my VM, because you know, I have that directory accepted from Defender. So that's why I put them in there. No, they shouldn't have been in that directory. No, because they wouldn't have been in public. They would have been in the root, and I have private public there, and they would only have been to in my private repo then. So no, they shouldn't have been there ever. So my food is beeping like crazy downstairs. Let's put this phone up here if we need a camera. I guess I'm a bit sweaty still. And not at all water or sweat running down my back at all. There, so if we need a camera from the top, we have one. So the lights are on. Let's turn that light on too. So anyone else annoyed with the new phone app, Twitch phone app? It keeps popping up people I don't want. I hate the front page of normal
Make sure
Twitch.
to not have private stuff on GitHub XD. Private repos and deleted ones aren't a way once a fork exists, or they were public before.
Yeah, so I made a new repo when I made a public one, and I didn't have any secret stuff in the private one either. It's just stuff that's not interesting, like what plans I might have to make for a YouTube video and stuff, you know. Yeah. So I didn't have anything. It's still public even if it's private. Even though I feel like everything I put on my computer is not safe, you know, everything I put in a connected device, I've always felt like that. So if I were to put something secret somewhere, I wouldn't really feel, and I don't have anything really secret, but I guess API keys and stuff would be kind of bad to make public. So I'm just trying to find where my stream is. So there's creator dashboard there, stream manager, and then it started audio. I didn't click a thing, okay? Automatically with a new app.
If you are using Android, take a look at Revanced. It's an app that can patch YouTube and Twitch to have a few nice features.
Okay.
Also, there you have the old nice app design.
Can you stream to Twitch from there? Because, you know, that's what I want to do too. So I might have to still use this and raid and control chat as me. If you can do those things, then I like it. So otherwise I'm kind of locked to what they do. So I'll go check with my kid and get my food, and then we'll get started. And we're not going to do buffer overflow prep because this requires pre-knowledge, you know. So I found another room that's called, let's see, buffer overflows. So we'll start with this one.
Yes, it's like the original app, but patched the nasty stuff out.
Oh, nice. So they just got the app and changed it. Okay. So is it the new app or the old app? Because I think I got it yesterday or something. In the weekend at least. So I'll go to check with my kid if he wants food. Yeah. I'll be right back. Let's see. So let's scroll a bit here. First, actually, let's start the VM. Not that it takes a lot of time, but my Kali one. We'll see what we need. But the last one we needed to RDP. So then I want this one anyway. So Kali and play. So let's click the start button there, and I'll be right back. I'll just go. I'll get more water with this too, because it's hot food. Linus, vill du ha mat?
Fixerbot says.
New follower inflict. Less than 3.
So, let's see. Actually, I can't see OBS. Thanks for the follow. Right, yeah. You'll get an echo if I don't have one of these in my ear. Revanced. Yeah, let's actually open that. Without double V's. I don't know. That might be a better Google, right? Revanced. Yeah, this is good enough. Alright. That's annoying. Let's actually move these ones. So I usually try to not have that many tabs open when I stream. But now I have so many things. Lots of this is actually research on fixing that VM, you know. But some other stuff too. There's lots of VSL config. I try to change stuff here. Did I remove this file? Well, we won't fix it now. Yeah, and I was going to get more allergy meds, but I realized I had it already. I could just order it on the website this morning. Yeah, because someone mentioned they did this. Well, let's not load all the tabs. They could stay asleep. Also found some of my TryHackMe notes. So I started moving this, or rather I copied this, but there are images and stuff, so we'll have to go through it and make sure I have all of this in my Obsidian notes. So I've been saying like, oh, this is supposed to be in my notes, why is it not there, you know? And I think that's it. So actually, I think I ate all my chicken in this, so it's only veggies and rice, but that's great too, and it's strong, it's hot. So, very hot. So we'll see how much I can eat without just... right, let's log in. I'll actually do a very quick bathroom break too before, so we have a good board. Yes, gubben. Behöver du hjälp med något? I had to help my kid again with the food. There's no, it's done. He said he could do it himself, but it was like putting the dough out, putting on the tomato stuff. And I asked him, do you want to put like the ham and cheese on himself? But then there wasn't enough of either of them in the packages that were out, so I had to help him. Yeah, so let's get started. I think we actually used quite a few minutes here, so let's actually put a marker on the streamer. So I can just do like marker here, and I will see it later. So let's move this one over here, right? And you can see that because
Robazro says,
marker.
sheep viewers on, web link.
Okay, so that you should ignore. So I think I could possibly like delete message. So I think I learned how to do it now. Right. So I learned how to delete messages, at least on my phone. So this isn't a way. Let's put that in a good place. Like in the drawer there. So sorry for taking such a time to get started here. So this one is working. We have YouTube and Twitch online, and we have a page up. We started it like 15 minutes ago. So buffer overflows. Learn how to get started with basic buffer overflows. And we should probably ask them to add this as a hint here that this room exists, that you can do it first. Buffer overflow room. Yeah, we'll make notes on this, of course, right? So let's get the notes up. So,
Fixerbot says,
New follower, how many can you fit inside you? Less than 3.
welcome and thanks for the follow. Well, some people have odd names. I wouldn't have selected that name. Well, would anyone? Someone did. Let's see. Debugging the VM, right? Yeah. So, let's actually add some new notes. I guess this won't be like a box thing. We rather make some notes down here. So we don't have anything on buffer overflow. So let's make a new number here. What number should we put it at? I guess we'll just do 27. I can move stuff around later if I want to, right? So a folder 27. Buffer overflow. And if I already have one and I'm missing something, I might, there. So let's make one for buffer overflow for now, and then we'll see what we'll do. So let's make a new note, and so it actually, that's annoying, right? That it closed one because I created a note. You shouldn't make a new tab, or you shouldn't hop to it automatically. That's what I would prefer. So I don't know even what to title this yet, except for buffer overflow, right? Well, I guess we go to the room and read a lot of stuff and learn things, right? Introduction. In this room, we aim to explore a simple stack of buffer overflows without any mitigations on x86 64 Linux programs. We will use, I've used this tool, R2 to examine the memory layout. You're expected to be familiar with x86 and R2 for this room. We've included a virtual machine with all the resources to ensure you have the correct environment and tools to follow along. To access the machine via SSH, use the following credentials. Yes, I'm kind of thinking maybe we don't need another machine. We will of course look there, and then we'll see. Yeah, so let's click this one, and let's search our notes. Because it's in here somewhere. So, oh, okay, so yeah. So what is this? This is Bandit. Notes 2. This is Valley. Right. So why don't I make notes of everything? I really should. So if I use a tool, I usually, yeah, so here I have some notes too in the colorful. So I already have it, you know, you don't need to install it. A executable file name. Right, I remember this. But I don't, this is not a lot of notes. Well, let's check this thing. Oh, I remember now. So when we do this, yeah, because it was like packed. So when I unpacked it, then we could run it again, because I found this information here. It's hard to see, but it says this file is packed with the executed packet. There's a link for it, you know, to UPX to unpack it. And I think it was very simple there. Just already installed also in Kali. Just to unpack it, and then we got strings from it, from this R2. So when we run R2, we got strings from it by doing this. But I haven't used it for anything else. I mean, it's definitely can do other stuff, right? We're supposed to be familiar with it before we start this room. So then we'd take another step back and make sure that if there's a room on this, you know, we might just learn it anyway, you know, but because I just, you know, I just googled here to find this. But I didn't have, yeah, so I didn't say what this does. That's what the most thing I missed in this here. And this will list strings. Let's just to list strings, right? So this is a better version of doing strings on something. So we have, actually this one should be like this and like this, right? So it's obvious. So yeah, so I got the ones I needed here at the top for this.
LHNN says
Another one.
Best viewers on web link.
So why this stream? I should fix this. I should make these auto remove. So anyway, I have my phone up there, but it's behind the mic, so I have to go like this, because it's sitting in the charger there. So this one we looked at, we didn't look from over the wire. This was one of the suggested tools to check here. And I haven't yet. Buffer overflows. Okay, so this is my notes. So I had started this room, as you could see, right? We have actually the first ones, they're checked here. So these are the notes from when I started it. And this was actually then sent from me doing other rooms here, apparently. So we'll have to backtrack to where I know what I'm doing, you know? So, yeah, so we already have started notes on this. We just need to move them. But this is a room. This is all of the room notes. I used to do this before. I don't do that anymore. I like to only take what I think is useful. But let's just make new ones, right? But it's still annoying to have double things. We can still find this. Let's keep it up for now, and we'll find it. So this is full log. Yeah, so this is just over the wire, all of it, I think. Just it's in the login information when you start. Well, let's open it here. So it's here in the when you start the bandit, when you connect with SSH, you get this as a part of the text. That's why I have it several times here. So we can just ignore these. Oh, now it smells pizza. I'm getting hungry. So my food is kind of mostly carrots, it looks like. But this food is extremely spicy. Yeah. So this one, let's just find it. I've looked all of this place. Let's reveal it in navigation, and let's move it. So I put it together with some other TryHackMe rooms there. It's not like it's the wrong place or anything, but whatever, let's move it. And I'm not making this kind of notes anymore, but we might. I don't want to have the full rooms also in my notes. This kind of feels, not the best way. So first of all, let's rename it. I know that some people have this all over the internet anyway, so it's not like it's. If this were not a free room, I don't know if it is or not. To have it all in my notes would be like kind of off, right? So this is the same as the actual room. So let's go back to the room and let's look there instead and close this one. I'm just checking. Yeah, so that was one I opened. This one was the untitled one. What's this? Oh, so I found some other notes. This was also moving from my docs, Google Docs. And this is from Google Docs, lots of stuff. We'll do this later. And both of these two are the VSL debugging. Though I kinda did all the things I found. We won't do that right now anyway. I kind of feel it's boring for stream too, right? To debug stuff. Though it might be, you know. Someone might not think that way. I don't know. So let's make new notes. I'm actually going to move this to the right side here. So my right screen. So we have this free for reading. And I'm going to start reading again. After the mess. So, buffer overflows. Learn how to get started with basic buffer overflows. And I'm thinking, should we reset it? What kind of questions do we have? Oh, very simple ones. It's not like we would have to think here. So we can just leave those. We won't miss anything from not resetting it. In this room, we aim to explore simple stack buffer overflows without any mitigation on x86, 64 Linux programs. We will use Radar 2, and we also click this. Might be some help there to examine the memory layout. You're expected to be familiar with x86 and R2 for this room. We have included a virtual machine with all the resources to ensure you have the correct environment and tools to follow along. To access the machine via SSH, use the following credentials. So let's actually connect there, right? Let's do it. First, I'll just start the VPN. I didn't do it. I don't know why I even would care to, you know, to not show this, but so I think you got it right. No, I was going back there. No, that was the wrong key. Too complicated passwords. Right, I should start the voice recognition. There. So, cause I was thinking like, oh right, I'm talking too much. If someone types anything in chat, the TDS will never actually do it because I'm constantly talking. Right, so let's get another terminal. I did click. Let's see if we get 2 now. So we go into SSH to right. User 1 at 167.49, and the password is user1 password because it's very important to have different password for the different users, right? I did type it right. 10.10.167.49. This is slow. Do I have to update my VPN? Maybe I do, because they sent an email. Yeah. Okay. So first of all, user 1. Oh, it smells so good, pizza now. I think I started eating. 10.10.167.49. That's correct. And user 1 is what I typed. And we didn't get a question for password. So that's a bit odd. Let me just check my VPN. So it didn't work. I just assumed it worked. So I got that email. Let's just look at the email. I guess I should have done this before, right? I got an email that you have to get a new VPN. So, just checking my email. Doing TryHackMe. It was a few days ago, so it's searching and searching. So I'm not showing my email on stream, sorry. I'm now live on my channel. You're right, those, so here. It actually was Wednesday I got the email. So
Influx says, are you requesting a new VPN?
So I got this email there. We have to get new ones. VPN changes. So I'll have to do that. It'll be quick. I'll just open another Firefox here on my other screen. And then we will go to TryHackMe first of all. And then we go to Access pane that I don't know where it is. We'll see. Access. And then we have right, I see. Download configuration file. So I was thinking I need to regenerate, right? And wait 2 minutes. Wait 2 minutes. Why wait 2 minutes? Let's see what happens when I click download there. Right? So I got my file. I won't open this file on stream. Right. So let me actually move this window over there. And let's hop back to... So I'm just curious about the wait 2 minutes. They're just trying to not get as many support calls, right? Yeah, I got another email. We highly recommend reading the Access OpenVPN guide. So, email closed. I'm going to do graphical stuff in Linux. That's not my thing, but that's the way it works with the dragging files. I can drag this file all over the screen to this, and I can only apparently drop them on the desktop. That's how it works. So, come on. I did click something. Yeah, and we did actually open... Do I have 2 Kellys now here? I did. So I'm just closing those windows. Let's see here. Right, so you can watch this, of course, if you want to. I'm just like, oh, this is the graphical stuff. How does this work? So in Kali, I think I have them right here. And I think that the TryHackMe one. So Fixit 42 is what the new one is called. And I'm like, that's the, yeah. So we will rename this one first. Ooh, it looks like that. I'm like, ooh, and I want to lowercase it. Because it's annoying to have to type mixed case stuff, right? And let's just move it here. Ooh, it worked. I was dragging a file in Linux. So, and these are the old ones. We can just delete these. What I'm sad about, that I'm assuming I will get a new IP. I've had the same IP since I started. And all my scripts, you know, rev shells and stuff, and executables too, MSF Venom, payloads, everything is using that IP. So we'll see. I guess I will have a new IP, I'm assuming. So, I'll also assume I can delete the old ones. So now we can close the strange stuff and go back to the normal stuff. So let's nano thm.sh. And this is now called Fixit42 because I changed my name. I used to have a Sophia75 there. That was kind of long ago though, but my VPNs was still on that. So I think that's the file name. And then we can just do my normal sh and type the password. And I'm assuming that we will get a new IP. Oh, it's not that far from it actually, but still, I used to have 10, 21, 32, 236. So I'll need to learn. This is kind of easier, an easier IP. But I still need to change all of the things, right? So CD shells. Here, all of these files have this IP in them. Almost. There's a few called HTB or something. HTB. And this is just me misspelling. It's supposed to be. It's probably THM, this one. Anyway, a lot of work. Oh, that's so annoying. Whatever. Let's continue. So we have the new VPN. We're connected. Let's go back to what we were doing. What were we doing? We were doing this. So yes. And what was it? User 1. User 1 password. So, and I still have my food in front of me, reminding me that I'm supposed to eat something. Very strong. There's a few tiny bits of chickens. There's a tiny bit of chicken. Yummy but too strong. I'll actually my eyes are yeah, so next time I'll try another sort that I can like eat more. So I'm ready, I think. For me, that is strong at least. So, we have connected process layout. When the program runs on a machine, the computer runs the program as a process. Current computer architecture allows multiple processes to be run concurrently at the same time by a computer. While these processes may appear to run at the same time, the computer actually switches between the processes very quickly and makes it look like they are running at the same time. Switching between processes is called a context switch. Since each process may need different information to run, e.g. the current instruction to execute, the operating system has to keep track of all the information may need in a process. The memory in the process is organized sequentially and has the following layout. So, I'm thinking, let's keep the image, right? So we'll copy this image and let's put it to the notes over there. Right. So I intended to have them on this other screen. So memory organization. Well, memory layout. They use layout. Let's do layout. So the stack. Let's keep the image visible there. So user stack contains the information required to run the program. This information would include the current program counter, saved register, and more information. We will go into detail in the next section. The section after the user stack is unused memory and is used in case the stack grows downwards, so the stack grows this direction. Shared libraries regions are used to either statically or dynamically link libraries that are used by the program. The heap increases and decreases dynamically depending on whether a program dynamically assigns memory. Heap. Notice there is a section that is unassigned above the heap, which is used in the event that the size of the heap increases. The program code and data stores the program executable and initialized variables. I'm thinking notes. It's like they're saying, where it says shared libraries, that's shared libraries. It's not really adding a lot of information, that's right? Except for the directionality of the growth. We could add that, because I'm making notes public, you know? So if there's anything else you think I should add, you can tell me. The stack grows. Let's just do downwards. Yeah, let's make it simple and make two synthesis grows upwards. And I should really practice my typing, right? So I look a lot at the keyboard. So, and where is dynamically allocated memory stored? Where is information about functions, local argument stored? Yeah, so actually maybe I should add more stuff. Let's make this different. Right? And I'm not good at this. I need to be better at this. What's where and stuff. Yeah, I kind of know that. Yeah, I guess I know it in one way, but let's anyway check how they formulate it. So I think they're actually not very pedagogical about it. So I did this other room. I guess it was one of the others we saw in the notes there with x86 assembler and stuff, where you could really see how it grew, you know, and there was a graphical, like you could step through everything, and it was very nice. That was nice. It contains. So I'm actually typing on this screen. Let's call it buffer overflow for now, right? And we can change the name if we want to. Contains and I had a full sentence there. Oh well, let's just list stuff. Contains a program counter. We can add stuff as we go, you know. Saved registers other information. That's a very good thing to add to a list. We will go into detail in the next section. It's what there, you know. They say more information. I did other stuff. Well, other info actually too. So contains I think my hair is back to normal now from biking. The heap increases and decreases dynamically depending on whether a program dynamically assigns memory. Notice. Let's add an A there, and let's do. That's the first thing they mentioned. Notice there's a section that is unassigned, which is used in the event the size of the heap increases. Program code and data stores. Program executable and initialized variables. So this is not good enough. I need more details. So it's in the next section, it says. Let's continue, because I want all the information, you know. So instead of trying to figure it out for yourselves, you know. The stack bottom of the higher memory address, stack top of the lower memory address. We don't need this image. A program would usually comprise of multiple functions, and there needs to be a way of tracking which functions has been called and which data is passed from one function to another. The stack is a region of continuous memory addresses, and it's used to make it easy to transfer control and data between functions. The top of the stack is the lowest memory address, and the stack grows towards lower memory addresses. The most common operations of the stack are pushing and popping. Let's actually add pushing and popping to the nodes. It's such basic info, you know, but still. It's still kind of good to... We need to remove there instead. To have it. So... the stack. I mean, I have the start of the sentence there, so how do I formulate it? The stack... well, let's skip that and just do it in sentence randomly. Data is pushed onto... well, I guess I have to say the stack. And... popped. They say pushing and popping. Well. Let's actually make a new area here. And this one too. And this one can actually get like a header. A little simple header. There. So now we have examples. So push var. This is the assembly instruction to push a value onto the stack. It does the following. Uses var or value stored in memory. Location of var. Yeah, I'm sorry that I read slow because I'm thinking all the time if I should add it to my notes or not. I'm kind of thinking how to organize the notes so that we get all of this. But I'm thinking also... let's read it all and see what's the best. Since this is pink and pretty here, you know. Pop doesn't get the pink. I think it had actually last time I read this. This is the assembly instruction. Yeah, so decrement the stack pointer. Let's hop to a new section. More like practical, right? Assembly. So let's push var, right? And we're going to push pushes onto the stack, but I'm kind of thinking how will I most simply uses var or value stored in memory location of var. And let's make it the way they do it, right? So what they do, they say in steps what it actually does. This is what we should do too. Right. So tabbing and dots is a bit messy in Obsidian. So, but I think this is right. I somehow managed to get this not to be a dot. So now it's a dot again. And if I tab before, it's not. But if I put a dash something here, then it's a dot. That's so annoying. Well. So did I change my mode? I'm in line preview mode. Okay, whatever it wishes. Doesn't have to be logical. I guess we are supposed to do this. So put yours onto the stack. Decrement stack pointer by 8. Well, 8. If it's 8. Decrease. I'm thinking the forms are making this more messy, right? And they are also saying decrements. Well, decrements. I'm sorry for this being slow. Stack pointer. RSP by 8, and I'm actually doing this instead, I think. Right. So this is obvious, right? Decrement stack pointer RSP to 8, writes value 2, where RSP points, right? Well, let's do RSP with that. So pop bar. This is an assembly instruction. Yes, now we have pop bar instead. So I think I guess I used these like so long ago. What could have been? 1980s, maybe? Oh, I didn't want you to remove what I just typed just because I pressed enter. Obsidian. You can't just delete stuff. This is an assembly instruction. You need to read the value and pop it off the stack. It does the following. Read the value. Reads the value. Well, this is so simple, you know, but well, this doesn't say in the page, but I'm going to type pointed to, right? And if someone doesn't think it's simple, we can dig into it more. Reads a value at the address given by the stack pointer. Stack top, memory location, 00 RSP point 0. Store the value what was read from into var. Increment stack pointer by 8. And now they don't do increments. So this is what I was thinking about, how to write this in a nice way. So I think I will remove the S from decrements. Decrement stack pointer RSP by 8, write value. Write var. I'm doing var. Right? So we don't have need that complicated explanation. It's very simple. Increment stack pointer. So, and the 8 is, well, you know. It does the following. Read the value at the address given by the stack pointer and stack top, memory location territory RSP point there. Store the value that was read into var. Important to note here that the memory does not change when popping values of the stack. It's only the value of the stack pointer that changes. The memory does not change, you know? This is an odd thing to say, because we store a value here into some memory, right? Well, I don't know what they meant. Each compiled program may include multiple functions, where each function would need to store local variables. Arguments based to the passed to the function and more. To make this easy to manage, each function has its own separate stack frame. And this is an important thing. This bit here. Where each new stack frame is allocated when a function is called and deallocated when the function is complete. So I'll need to look more at memory while like doing this, right? Because it's not totally clear how it looks in my mind. I mean, is there something? Is it adding extra stuff? That's what I'm thinking. Right? So I'm pasting this text here. Each function has its own separate, is like own and separate makes it redundant. Where is new stack allocated when the function is. It doesn't say where. That's what will be interesting. Stack frame is allocated when a function is called and deallocated when the function is complete. Where? We'll see. We need to know all the things. This is easily explained using an example. Look at the two functions. Add int ab, a new int a plus b, return new, int calc ab, int final add ab. Okay, so this function calls this function, and the main program calls this function. Okay. What direction does the stack grow? So they say it's easily explained with this, but they don't explain anything. So let's see if they do this here. Let's hope so, right? So, procedure is continued. The explanation assumes that the current point of execution is inside the calc function. Yeah. So they are continuing. In the case, calc is known as a caller function, and add is known as a callee function. The following, what? So add is called by calc, not the other way around. Let's read this again. And the scrolling. Couldn't they just, when you open one of these, put that on the top, not the bottom of it, right? That's what you want. That's odd. In this case, calc is known as a caller function and add is known as a callee. Okay. So this is a called one. Yeah, I guess I didn't really read that. The following presents the assembly code inside the calc function. I can't read this. If I click it, I think it's better, right? No, this is still not readable. Gray and blue. So I guess I will try. So a bit better, right? One more. var int local underscore 18h, and these names are then used here. Are they? No, that's just the @RBP. So apparently I don't understand this. There. Let's just we have the other code to compare with. So let's hop back here and see what they say. So we have this one easily available. The add function is invoked using the call operand in assembly. In this case, call qsim_add, and let's look here, and we have it here, call qsim_add. So didn't I have a good size anyway there? There, now we can see it all. I don't want to scroll in that. The call open can either take a label as an argument, e.g. a function name, or it can take a memory address as an offset. Or it can take a memory address as an offset to the location of the start of the function. Okay. Yeah, that's logical. It's either a name or the memory address. I was thinking of the arguments already. of a function in form of a call value. So once the add function is invoked and after it is completed, the program would need to know what point to continue the program. To do this, the computer pushes the address of the next instruction onto the stack. Yeah, this is again basic for me at least. In this case, the address of the instruction on the line that contains movable EAX. So if we look here, movable EAX local 4H. So here of course in the function, or rather, seriously, I'm like, is this where it saves it, but it's calling it here? Let's see what happens afterwards, because this is the other way around. After this, the program would allocate a stack frame for the new function. Change the current instruction pointer to the first instruction in the function. Change the stack pointer RSP to the top of the stack, and change the frame pointer RBP to point to the start of the new frame. I'll have to reread this. After this, the program would allocate a stack frame for the new function. Yes?
Nigrisa says, H inverted exclamation mark. Translated from Vietnamese.
Change the current.
Dick. Translated from Dutch.
The TTS is a bit funny. Change the current instruction pointer to the first instruction. Yeah, sure. If I can answer, I'll be glad to. It was, a normal question.
I have a question.
Shouldn't be before the TTS. But right, last stream when I did this hop from biking to by the computer, I missed to turn on the audio. And now I'm sure I did that, so that's good. So yeah, I can hear the TTS, right? I think so. I unmuted desktop audio, so never say I have a question. Say what the question is, right? I'm just waiting now. The program would allocate a stack frame for a new function. So I want to see this physically, in the memory. Change the current instruction pointer to the first instruction in the function. Change the stack pointer RSP to the top of the stack, and change the frame pointer to the point of the start of a new frame. So I don't know how these frames work, so I want to see it. Is this what they're trying to show me here? Previous stack frame for calc, return address, still part of calc stack frame of
Looking to my router when only one device is connected. I see 2 MAC addresses in DHCP1 with host name and their one blank. Is that normal?
One device is connected. Well, I'm assuming what are you looking at? Like your internal side? Because there's two sides, of course.
Host?
Yeah. Yeah, so the TTS I didn't even mention the character because I read it. So if you have a outside network, you have your router, and you have an inside network. So of course there has to be two. Without two things connected to the router, you couldn't do anything. But I don't know where in it you are, so. But maybe that's a better question for the Discord. You could send like screenshots and stuff in the Discord if it's not secret stuff, and ask there. So it's kind of hard to like pause the stream for that kind of thing, right? So we have an image here, but it doesn't tell me much. I'll need to look more at all of these things. So, right, I'm tabbing over to OBS. I was almost saying Obsidian again. I did that the other day, saying Obsidian instead of OBS. Let's say that when you're typing in Firefox or some browser, it's the same thing. You get the wrong thing all the time. Once a function is finished executing, it will call the return instruction rec. This instruction will pop the value of the return address of the stack. Deallocate the stack frame. For the add function, is change the instruction pointer to a value of the return address, change the stack pointer or speed to the top of the stack. Change the frame pointer to the stack frame. So this is what's new to me here, the frame pointer to the stack frame of calc. So I need to know how this works. I need to see it's being stepped through in detail. So this is like not good enough for my brain. I want all the details, not like a general kind of thing. We'll see what we get. Let's read this one finished, and then I'll read it again probably. Now understood. This is always funny. How control is transferred through functions. Let's look at how data. I'm assuming they're just wanting us to know that stuff is put on the stack, and I want all the details, and you're not supposed to, are you not? In the above example, there's probably a reason why I stopped reading this room, right? So I had done this far, and then I just stopped. But I guess this is one. When you're doing rooms, there's like suggestions. Do this and this and this too, and you like fall off the path I'm following. Alright, so is there like a path for this kind of thing? Maybe like a. I guess they're not, right? There's no path for this. It would be nice to see which path will this room be a part of, right? It's not part of any path, or is it? We don't know. The age of this. So, I have like in my head, the processor and the registers and the memory and stack and stuff, and it's not fitting the puzzle pieces. I need to know more details to make it fit in my images in my brain. Now that we've understood how control is transferred through functions, let's look at how data is transferred. In the above example, we see that functions take the call function takes 2 arguments A and B, up, and 6 arguments for functions can be stored in the following registers. Array X is a special register that stores the return value of functions, if any. So RDI, RSI, RDX, RCX, R8, R9. If a function has any more arguments, these arguments will be stored on the function's strike frame. We can now see that the caller function may save values in the register, but what happens if a callee function also wants to save values in the registers? To ensure the values are not overridden, the callee values first save the values of the registers on their stack frame, use the register, and then load the values back into the registers. The caller function can also save values into the caller function frame to prevent the values from being overridden. So the frames are actually not like only step on it, or we can actually access them there. Can we? Or stacked on top of under each other. Yes. Here are some rules around which registers are caller and callee saved. RAX is caller saved. Or called save. They're usually arguments for functions. Caller saved. Callee saved. RBP is also callee saved and can be optionally used as a frame pointer. RSP is callee saved so far. This is more thorough example. Yes, I really want to read something else on this, right? Because I don't have enough information. So this is why probably I stopped doing this room, because it's not enough. It's not enough information. It's a bit of a mess. All TryHackMe rooms are not good. So also that they say a thing like, now that we understood, you know? And most people who look at this room probably don't know exactly what happened. Because, well, maybe they don't want to know exactly what happened, but I want to know exactly what happens. So there's 2 ways to handle that. That's digging into it more, and there's skipping over it for this time and going back again later. I don't know. Let's take a few bites while I think. If I just eat this, though it's too hot, what will happen? We'll start crying. So the image in my head is now we have these frames added on the stacks, and we can go back and edit the data there. It's a mess. I don't know exactly how it's. We're not just pushing and popping now. Now we're going back and editing things in there. I have no idea. We'll give this to ChatGPT and we'll ask it to give us more details. And then we'll have to double check, of course. It's very hot. So, I don't want to Google, and exactly find the right page. We could be doing it for ages, but here we can get a bit. I want to know the details. How this works in memory. Stack. Especially access to the frames. I just pasted that tasks text in there too, to make it know what we're talking about. So, to understand how function calls and data transfer work in memory, specifically regarding stack frames, let's break down the detailed explanation provided. Okay, let's see. Function invocation with call queue. When the calc function calls the add function using call queue sim add, the call queue instruction does several things. It pushes the return address, the address of the next instruction after call queue, which is onto the stack. This ensures once add finishes, the execution will resume correctly in call. Yeah, so this is simple and logic, nothing strange. And then it allocates a new stack frame. And what I want to know here is where on the stack, I assume, but details. Changes the instruction pointer to the address of the first instruction in add, adjust the stack pointer is P to the top of the new stack frame. So on 1, where and how is the stack frame allocated? I'm guessing I will get more information later here, but on the stack, I assume. Maybe I should read before I ask, so the answer won't be there. Just a stack pointer to RSP. How does the frame pointer work in detail? Yes, I guess I should always add in detail, right? I always want details. So let's see how much more there is. It's quite a lot, but it's not more detail, I think. I think it's too short. So let's do this first. When a function is called, the stack frame is allocated on the stack. Here is a detailed step-by-step process how the stack frame is allocated and managed during a function call. Calling the function, this assembly instruction performs a function call. Push return address. Well, it's just pushed. Setting up the stack frame. Allocate space for local variables. The stack pointer RSP is decremented to allocate space for the called function's local variables. This space allocation is usually done by subtracting the required size from RSP. Okay, this is more detailed. This is more what I want. Set up the frame pointer RBP. The current value of the frame pointer RBP is pushed onto the stack to save the previous stack frame's base address. Yes. Right. So it's like the base address and where the stack pointer is. Or is it the base address, the lowest address? The frame pointer RBP is then updated to the current value of the stack pointer. The new value of RBP makes the base of the... Yeah, so let's read this again. I think I will get it. The current value of the frame pointer RBP is pushed back to the stack to save the previous stack's base address. So this is called the base address here. The frame pointer RBP, the same one, is then updated to the current value of the stack pointer. This new value of RBP marks the base of the new stack frame for the add function. So I'm thinking this is before then. So this won't be updated then later. So that's how we know where the frame stops and starts. It's still not detailed enough. Detailed frame pointer mechanism. The frame pointer RBP is used to provide a stable reference point within the stack frame, which simplifies accessing function parameters and local variables. Here's how it works in detail. Prologue of the called function add. Save old frame pointer. Pushes the current onto the stack. New frame pointer. Copies the current value of the stack pointer RSP to the frame pointer. just looking at the skin. So I have bamboo stuff in my teeth. Oh, chicken. Ooh. I'll just eat a bit more. So this is why I prefer learning from people. Oh my goodness. But when do you ever? Mostly like this, right? So this will make the other stuff more clear, I'm assuming. Assigning parameters and local values. Parameters passed to the function are accessed relative to the frame pointer, RBP. For example, yeah, this is what I assumed. The first parameter is typically RBP plus 8. Consider the return address is its RBP plus 0. The local variables are accessed using offsets from the frame pointer, RBP. For example, the first local variable might be RBP minus 4. Okay. Because they're put there before. We're still in the frame then? But it's minus. Yeah, local variables are after. And these are, of course, parameters before. Only that it's upside down. Backwards. Function epilogue. End of add. Restore old frame pointer. So this is, I was just, the real interesting bit here is that this does not actually change, it's just referenced with different plus and minus here. That's the interesting bit. So now we have confirmed this does not change while we're using this frame. It's just stuff like this. Move REP RSP restores the stack pointer RSP to the value of the frame pointer. So we're going back. This efficiently cleans up the local variables. Restores the color frame pointer by popping the same value of the stack. Return to caller. Pop the return address of the stack and jumps to the address, presuming execution. Oh, nice! It gives us an assembler too. So, simplified example to illustrate the process. Very simplified. Save the old frame pointer, set the new frame pointer, allocate space for local variables, 16 bytes. Example of saving a local variable. Leave. Okay, so that's an alias for these. Return to cooler. Okie dokie. So, do we know how this works now with frames? Much better picture from ChatGPT actually. Then we have a bit more information here. So here's the typical layout of a stack frame. Parameters for the current function. Return address, pushed by call queue. Saved frame pointer. Callee stack frame, local variables, temporary storage, spill area for registers. The stack frame for a function is allocated on the stack by adjusting the stack pointer. The frame pointer RBP provides a stable reference for accessing function parameters and local variables. The prologue of the function sets up the stack frame by saving the old frame pointer and updating it to the current stack pointer. The epilogue restores the old frame pointer and returns control to the caller by using the retq instruction. Okie dokie. So we hopped a bit up here, right? So yeah, so we have already read about retq, data transfer and register usage. The first 6 arguments to a function are passed in the registers. Well, this is just what the room said. Register saving conventions. Registers that the calling function calc must save if it wants to preserve their values across function calls. These include caller saved registers, registers that the call function and must save and restore. Given the provided explanation, here's a detailed look on runtime stacking. So, calc is executing with its own stack frame before calling add. The instruction pointer is at the call queue sum add here. You missed the bike ride.
Panda Tongue says,
I missed the bike ride again.
So, too bad. So, possibly, do you think I should do it tomorrow too? Then something past 12, my time. So, something past 12. So it is now, oh my god, what happened to the time? It's 15. So I think we actually started with this at 13:30 because I was helping my kid with the food and stuff. So well, it's saved there if you want to watch it. I guess it's not the same as talking to me while I'm buying, right? I even forgot to put something like this in my ear, so I might not have heard very well because someone spoke, but I was like, did I hear that? Given the provided explanation, as we did look at the runtime stack during the call, again add function call. So the stack pointer RSP points to the top of calc's stack frame. Yeah. So calling simadd pushes a return address onto the stack, updates RSP to point to the top of the add stack frame. And here we're missing details then. Stack pointer RSP points to the top of calc stack frame. But this is the instruction, not the RSP, right? So RSP needs to be saved too. And it was in the other thing we read, but not here. So this is too little information. So we already know more from what we read before there. So add executes, set RB to address the first instruction. Add executes and may push values to save the current state of caller saved register if it needs to use them. Returning from add pops the return address from the stack update RIP to this address. Restore the, it's all of this, it's not complete. And it's ChatGPT. But the last bit there was better when I asked for more details. So summary stuff in assembly. So this is not assembly. This is ChatGPT typical. It repeats stuff like it didn't just say it. Yeah, so this was better. I think I'll keep this one up. Oh, we're already expiring soon. We haven't really even tried. We haven't really connected there, So, let's look at the image a bit. I think I will go down with my food because it's a bit too hot for me, this, so I won't eat that much at a time. So I still have some left of my too hot Thai food. I'll be right back. So when I walk up the stairs, I actually feel a bit tired in my legs, and downstairs too, or maybe mostly. So I did some good with the biking at least. So it's annoying when you don't get training aid when you like spend a lot of time trying to exercise a bit. So so too bad this isn't in text format, because we could just can it handle images now? I don't think so. Or we can't just paste an image, right? If I paste an image here, it's pasted. Can we do this? Nice, it could read it. Well, basic OCR, right? But I'm using the free thing. Let's break down the assembly code and understand how it measures stack frames of function calls. So it has the context already, because we're in the same thing. Function, semicalc. This function has two integer arguments, R1 and R2. Yeah, we can see that here. It's kind of tiny, so we can see it here at least. Then I'm thinking about the syntax of this. We'll see if it goes deeply enough, right? The function has two integer arguments, and it defines three local variables. The function calls another function. So it skipped the variables? That's what I was interested in. I wanted to show me all the details on the syntax of the variables. Oh no. Yeah, so it didn't start at the first line, so we can see it declaring variables. I want to know the details. What does exactly this mean? Right? RBP. Yeah, maybe I understand it myself now. RBP minus. So this is actually a calculation of a number. Yeah, I guess I understand it from reading the other stuff, right? And yeah, so 4, well, I'm saying 1 4 when it's 1 6 1 8. So maybe I understand it. I didn't need that explanation then. So let's just read it without ChatGPT. And also this column. Okay, so this is actual content, and this is the machine code, and this is the assembler. Is it? No, it can't be. It can't be. So what is it then? So here it puts the arguments. Let's read from the start. let's read its thing. But I still would have wanted it to start at the first line, right? Not just to skip lines, because it was just declarations. It's still part of it. This function has two integer arguments, arg1 and arg2, and it defines 3 local variables, and the function calls another function add, sim add. Save the old frame pointer and pushing it into the stack. And this column is not mentioned. Let's actually do. What about the variables? And the column starting with 5, 5. Yeah, it's a machine code correspond to the assembly instructions, but it looked so tiny. That's why I was starting it. Oh my god, my nails. So, okay, so what about the variables? It wasn't specific enough. What about the variable definition lines, I should have said. So it's going through the variables and all of it. Still not doing what I wanted. So, yeah, I think I need another bike break because I'm actually a bit tired. Maybe it's after food tired, I don't know. Right, so actually I haven't bought any energy drink for a lot of time, but I had one over here that was from before the vacation. So let's actually drink this now. So it's been standing here for weeks and weeks. So I did bike a lot yesterday, and I biked now to and from work. So right, I didn't sleep that well because my kid woke up. So he was coughing a lot. Poor thing. But he fell back. He actually didn't fall asleep until like 8, 9. No, 9 probably. Probably 9:30 even, or later. Because I was at work at 10, so I probably left about 9:30. Yeah, we'll see when he wakes up. He's still sleeping. I don't think those taste very good. And there's another sort that I like the taste of. And they had an orange flavor too, and I liked that. They stopped doing that. Maybe that was a good thing. It shouldn't taste good, should it? Then you want to drink it. So, where were I? Yeah, so it confirmed this is machine code. In one way, I would prefer to do that. I'm crazy, am I not? We did it actually when I was in like 7th grade. I think we did machine code then, or maybe it was the year after or something. So, but then I haven't done it much after like old computer games. Then you had to like change a few things. So it wasn't really machine code, just changing stuff later. But then the copy protection thing is got more complicated. When function calls another function. I'll drag a ban. Linus? Oh, I don't think he heard me. So let's just continue. So, we're saving. the old RBP here. Frame pointer. Let's actually start adding here. So frame pointer RBP. So I'm liking this. So this I don't like, that obsidian. When I tab in here, it tabs the whole thing. I just want to put a tab in there, please. Can I do that? No. So space instead. Frame pointer, right? We could make a table, I guess, but I don't like tables. Sorry, I'm not used to drinking anything with carbonated beverages. I just drink water all the time. Or probably if I drink something like that, it'll happen. I'll burp. Save the old frame pointer by pushing it to the stack. Set the new frame pointer to the current stack pointer. Right. So I'm thinking, should I make notes on this? Of course we need, and that's more important, we need the RSP. I was typing SRP rather. Stack pointer. So we set the new frame pointer to the current stack pointer. Okay. Allocate space for local variables on the stack, subtracting 24 bytes, this in hex, from the stack pointer. Let's see. This is interesting, right? This is one of the interesting bits. So let's have it big. Oh gosh. Do I have such tabbing problems? I'm tabbing to the other screen. I wanted to switch on the same screen, right? So, sub Q, well, 24 RSP. We just simply, no, let's not simply assume. Let's look at sub Q. Assembly. Oh, right. I have it set not to open stuff. Or PDFs, rather. An AI assistant here. I'm just opening a file, you know? Oh, right, now I can hop between the different ones. Yeah, this is a great document. Let's read all of it. So, I'm assuming it hops. Can this just stop? So I want the first one. So I was kind of assuming a cheat sheet, as it says it is. I was assuming a cheat sheet with a list of stuff, but it's not in the lists of stuff. Sub-Q is not in any of these, is it? Because that was arithmetic, so this is move. And this is memory then. We need more information. This was not good enough. What is sub? What is Q? Sub Q. Operation destination. 68. Let's do x86, right? Because let's do 64. Let's be modern. Subcube subtract. Oh gosh, and another one.
VR Mechatronics says, "Hi, how is going?"
It's going great. It's a bit slow though, but that means learning, right? So it's good. This was a funny document. So so I'm looking for more information about the sub-Q assembler instruction. And I'm assuming it's here because we searched for it here. Sub L sub Q. So I'm assuming the 32-bit version and the 64-bit version. Both of these work by adding or subtracting the source and destination values, leaving result in the destination. This was not that hard, was it? Was it that hard? No, I don't think so. Why couldn't it have been just... Why couldn't Google have just said this, right? Add... So these adds and the subtracts. So, since we're on the stack, we're subtracting when we're adding.
You speak good English, why not apply for job in USA or Australia? Do you have own home in Sweden already?
Yeah, I've got kids, you know. One 14 and one 16-year-old, but I could do remote work. So, if anyone want to hire me, I'm available. Yeah. So it's not likely that I'll move right now. At least both of my kids have selected English as their primary language, though. So, but I have my old mom and stuff, you know, family and friends and things. So 64-bit multiplication is weird. At least fail to make sense of the documentation. Also, I don't know what was the source of this.
So they not like English?
They only speak English. One of them is now trying to relearn Swedish. Yeah. They understand everything we say. We only speak Swedish to them. But we live in Sweden and they speak English. So, that's what happens sometimes. One of them, my oldest, has autism, and I think it's kind of common. And my youngest, he might have that too, but he's got ADHD, a lot of ADHD. So, and also he both crashed in school. It's mostly that, you know, they watch a lot of YouTube and other internet content. That's the language on the internet. So a short guide. Let's open these. All these actually pages. No, we got another PDF file. I saw that already. So we can read all of this.
But have you
So-
had job offers in the US already?
No. Though most people calling me or contacting me about work missed the bit that I was like can't do 100% on site. But now I changed my CV and my LinkedIn to be cybersecurity. So it kind of dropped the people asking me, but I've started to get people asking me again. But it's usually someone asks, well, this is cars and stuff. I'm like, I don't know anything about cars. You know? But I used to get a lot of people calling me about IT jobs. Well, we'll see. I'm hoping it will like... I did apply for one job that looks very good. I'm going to apply for more, I guess, because I can't just apply for one, right? Just assuming I'll get the first one. As a noob in this area, even though I worked in IT for a long time. Alright, I forgot your TTS. I will fix that. Wait a sec. So I started streaming when biking. That's why the TTS for YouTube is not running. So good thing I noticed. So we'll have to open this, and then I'll need this up again so I can see where I'm at.
My children did not get residence in Denmark, so I can move if I am left alone without my parents.
Okay. Share your career path, how you started. So I haven't worked in cybersecurity yet. So, but we can just generally talk. But there's also my LinkedIn link, you know, in my, though that's on Twitch, right? Maybe I should add stuff on my YouTube one too. So what's this? Oh, this was a VPN. So this window, we don't need this anymore. We can go to LinkedIn here, but I was actually going to YouTube. So, oh my god, what happened? Why do I get that? And what's that?
Dev Sutar says, I was thinking about some people are building such great open source application like Tor, OpenVPN, IP2 etc. This all are free,
Yeah.
but people are donate him? Or just using the free software?
I guess a lot of people that build open source software work with something else. But I guess some people may. So open source doesn't mean free either. So it could be open source and still they could be like making you pay for some services. Oh, so this just reminds me that I really want this kind of handle, and it hurts my hands every time I do this. And I try to like angle my hands to get more change, but I want this. So I can watch that. I think it's because I watched a video to confirm I knew how to fix my hobby's tires the other day. So we would just go into, is it the studio possibly? Or should I just go to the channel? To change.
I'm applying for a job at a federal financial agency in Python in US.
Okay, cool. Do that. Oh my, hair. I usually don't have this screen on because you can see so much of my room. Right. I changed the zoom because I noticed last day. I hope there are not a lot of stream, but the focus was off, so I fixed it a bit. But first I messed up and I took the back ring here and changed the, the zoom instead. So the focus is the one closer to me, which is kind of tiny.
Dev Sutar says the YouTube recommend you because of the algorithm if you see any fun related shorts, so they are showing the all fun stuff.
Okay. I never look shorts. I hate shorts. But that's might be a... Well, I'm not 15, you know? So you can go to my Twitch link here, but maybe I should add more links. So what happens if I do customize channel here? Because I'm thinking maybe I should add the other links just now, so they're there. Because I've thought about it several times when people asked. Like basic info, maybe? It's not branding, at least. So this is where the links are. We found them. So let's open Twitch too. And oh my god, it starts stuff. I hate the start page, and now the app has the same thing. It's horrible. It's so horrible. Channel. Here.
They have a problem with overdue loans, and I want to replace evictions from apartments with unskilled work for cities, so that people can pay off their loans. You know, I have experience in Denmark and in this topic.
Okay. That's great if you can find a good job. I know that you're trying to get into that course or something, right? In Denmark, trying to apply to university. But you could do that in US instead, right? If you want to. So I was just going to about. Sorry for being distracted here. So edit a button links. This is the same bit, but in Twitchies, or whatever we want to say. So here we have Twitch and YouTube. This is my other YouTube channel, and on Twitch I have Discord, LinkedIn. Let's actually add these. That's what I'm going to do. So let's copy the Discord one. There. And let's add another one and add LinkedIn. So if you're curious, you can just look, you know? And also,
my application was rejected 9 times, but I passed the online advanced placement computer science exam in Java in New York.
Okay. So we don't need this link on YouTube because it's there where you are, right? So, but my GitHub, we could copy the GitHub one too. So GitHub. We're going this, what is it, Fight Club style here. And the web page, it's not, you know, finished or updated or anything. Twitch, YouTube, Discord, LinkedIn, GitHub. Should I add the web page too? Let's do it. I'll have to fix the page, and also I think I will use another URL. So let's not add it for now. Okay. So this one we'll need to like publish. Right, and then we look at the channel again. And we have 4 more links now. So we have all of the things. So now you can join my Discord from here. You can click my LinkedIn from here. You can go to GitHub. So LinkedIn, that was a question, what I've like done, right? So I have updated this a bit. This is me selling like do-it-yourself stuff.
I have problems with grammar in writing, but GPT corrects everything faster than I can type text.
Okay. Oh, that's good. So here's like places I worked and stuff, you know. So you can go there if you want to. I'm thinking we can close these down so we don't spend too much memory of my poor computer. So I will have to get a new computer, and I just send the invoice to the ones where I do consulting. So we'll see if we can afford a computer. Maybe I'll just buy some parts, maybe I'll buy more things, we'll see. It was a long time since I built my own computer, so I've bought used ones, like gaming computers that people are like upgrading. Maybe someone is selling like their old motherboard, memory, and graphic card. Since they're upgrading to even cooler stuff, you know? And mine is like at least 10 years or something. I don't know how old this is. Maybe it's not 10 years. So, I need more memory, most definitely. And I checked the motherboard and there are no slots, so I can't just add more. Because I had more memory, but it doesn't fit. And my old motherboard that broke, it would have fit there. That's so sad. Either it's the processor or this motherboard, and you can't buy those processors. They're and the motherboard is like the most expensive thing apparently. To get back to this, we were actually going fine here, right? On the other ones. Looking for sub queue, and let's see if we can find the something here. The same thing. The something. It sounded like I said. So I'm sorry, but when I drink this with bubbles, they come just right up again. I'm not used to it. Should probably drink it, but anyway. I could have thrown it out instead. But I was tired, so why not use the last one and see if we get more. That lost sleep will still be lost, but still. So this is saying that this instruction actually does this, right? But we want the definition of the function. We want details, and that's not here. It's not here. So I opened another one that was actually a web page. Short guide to assembly. So let's do the same search. Sub Q. Subtract REX from RBX. And then leave the result in RBX, but it doesn't say, because why would it say, right?
Diablo 4698 says, Hi.
Welcome in. So, I'm just learning things. I was just checking for a definition of sub Q, but I think we're good, right? So okay, so here they do a C-ifying of them, and this is a good explanation. This is short and very more. I know that some assembly languages have these mixed spaces, the place of them, right? Or even not even processors, but subtypes, right, of assembly. So it's nice to know which is which. It's nice. So it's just two hits of this in the whole thing. CMP sets of flags. Alright, so that's just for that. Yeah. So here we have ink, deck, neg, not. And they're doing this the C equivalent. That's nice. So let's keep this page up, and we will probably crash the stream after a few more pages there, right? I have to get that new computer. I should have a new computer money collection thingy. I need it. Right, yeah, notes are on the right side, and so far we've only got a few things there. But this is very tight. This is really buffer overflow things we're looking at, but it's so tied to assembly. So we need to really repeat and learn.
VR Mechatronics says, in the USA they have cars that interest me, smile smile.
Okay, I'm curious what cars, if there's something special. Since I know that you're into mechatronics, VR mechatronics. Building your 3D thingies there. So what car could possibly be interesting? Some cool car. So we have read this.
Ram Pro Master L3H3.
Doesn't tell me anything, unfortunately. I want to check it now. So I need to focus on this. What register stores a return address? Okay. Yeah, so I'm like, what's the return address? Because we need to read a bit of this again. So I should know this instantly, but I don't remember it right now. So let's actually reread, because learning, right? So we have RBP, which is a frame pointer, and then we have, of course, RSP, stack pointer, and right, we were checking this. Where is it now? So many tabbings ago. So we checked subQ here, and it just removes this from this, which means the explanation of this was that it actually allocates, but it adds, well, you could see that I guess it does. It allocates memory on the stack, I guess. Right? Then we have the next one, and we were following along with the ChatGPT thingy here. I sent this image, and it is, we're going through it very, very slowly, because I wasn't pleased with allocate space, because it's not allocating right, it's just it's subtracting. I wanted to know more, so I know all the details about it. Now I know all the details. And similar ones too, right? Because you don't remember these for, oh god, I shouldn't say when I, right? 7th grade, I think, right? Save arguments and local variables. So, the move-al EDI, comma, it says it here, so we don't have to like go up and down. That's nice. Store arch1, which is EDI, into local, and then we have arch2, which is an ESI. So, and then we have
Yes, GPT is amazing. It push up education for all peoples twice x2.
Yeah, so I guess this room didn't really go deep enough from what I wanted, you know? So, and maybe it was just that it was assumed in the knowledge because it kind of said at the start, but it's annoying when it doesn't point you to the information in that case, right? And it's not like I don't know anything about it, so I'm thinking other people that never did assembler at all. I've done quite a few things actually in assembler, but not always x86 or x64, but anyway. So there, I'm assuming they should have like links to more knowledge, don't you think? So move. Oh, we already did these. No, these we did. Once again, let's actually read here instead. Move. Okay, so minus 14 RBP. Yeah, this is how we put this is the local variables addresses on the stack. So we put them into EDX and EAX. Oh, right, I remember the code. So the C code. Let's hop to the room for new people. Let's see, is it here? So this simple thing. So this adds, and it adds in here. So this is what they're explaining, but they didn't do it in detail, so I'm using ChatGPT too. But this doesn't really explain more than this does, right? Maybe. So, at least it says which is which here. So from this into this, which is the logical direction, as long as you don't think like you should be in like an equal character here. I guess it actually is here. No. Was this actually how the image is? Yeah, so then it is the other direction then. It's an like an equals character here. Like they typed it here. So now we need to Google Movell instead. Let's actually put this at the end. Because we need to know all the things, right? We can't just know half the things. We need to know all the things. I'm sorry. Moving along while you. So I shouldn't have drink this because my tummy got upset from the bubbles since they are not used to it. stupid thing to do on stream. Sitting here burping and getting a tummy pain. Oh, so at least we can see we already have this one up, right? Yeah, this is a nice one. Nice list here, registers. Can you hear my tummy? It's really going funny noises here. I hope you can't hear. Addressing modes. Direct addressing mode, indirect.
Wupinion says,
RAX.
Hello, Fixit.
Hello, welcome back, Wupinion. So. Yeah, so this is with a -2 that we're using right now.
I'm on HTB Academy right now.
Ah, nice. So I was thinking of that too, you know. Maybe when I've finished more stuff on TryHackMe, I might hop over there too. Since I'm paying for one thing, why pay for several things when you don't have more time to do it all at the same time anyway, right? Yeah, so this is the address is the base plus displacement -24. What displacement? Why? What displacement? Isn't the displacement -24?
I'm going to do all the lessons in browser and then probably pop boxes using a VPN and my own toolset.
VR Mechatronics says. Web link.
All lessons. So probably. Yeah. Your own toolset. So what are your tools? Tell me.
Wupinion says.
What's that? I don't want to click it.
Yeah, so I think VR is safe to click links from. So, cars. Was saying wanted American cars. So this was the kind of car then. Okay. Let's go back to the studying. So. Oh. Oh, I'm sorry. That's why I'm drinking the thing that makes my tummy bubbly. Because I'm not used to it. So.
VR Mechatronics says. This is my future company, building and this 3 cars. Wupinion says.
So I want to try writing some of my own tools to practice programming, and I want to build my own Linux builds instead of using Kali and the like.
Okay, cool. Yeah, so I think Kali is great, actually. So I don't see a reason to spend the time to... If it didn't, if it didn't exist, then you would have to, right? If there were nothing good. But making your own tools, definitely I want to do that.
Because before Kali, that's what you had to do.
Yeah. But you can just install, you still need to install some things, right? It's not like you don't know how to install stuff. Yeah. But I don't want to like make my own windows either and spend a lot of time on that. But I do want to make better tools, you know? Not just copy stuff that already exists or anything.
Panda Tongue says,
I was just thinking of you on this call. Troubleshooting this dentist's office 3D printer for dental implants. Really cool.
Wu Pinion says,
Well, Carly has a lot of bloat.
Okay, if you feel like that. I do the full install. I think it's great to have all the tools there, and I don't mess with it so much, so that I can just install the clean one and be pleased with that, you know. I don't change stuff so much. I'm gonna leave this desktop. I didn't even change the new ugly logins screen. Though it's kinda growing on me.
Horses for courses, etc.
VR Mechatronics says, GPT presented me with a 2-year plan to achieve my goal, and I am doing it.
Okay. Oh, well, do it. Go for it. Yeah. So I'm thinking, should I separate it, or should I put my assembly nodes into my buffer overflow, or should I just add like assembly 2? That's probably what we'll do, right? So let's rename this one because it's kind of low level. So let's just, so putting asm, you know, I have several others where several things in one. I'm so sorry. It's not my fault. It's this thing's fault. Though I drank it on stream, so it's my fault. But this lowercase, it kind of looks odd. Whatever. I don't care. It works. So let's put the other ones that were also, I think they were down here somewhere. Here. So here. So this is in my programming section, but this is information, meaning it's more like yeah. So let's just drag, let's see if we drag all of this out. So this is some other information source. Challenges. Yeah, so this is long ago notes. You can see that from the images being here instead of in an images directory, because I did it like this before. So let's add an images here. So let's just drag these. The links are updated automatically. That's nice. We can just let's move the full ASM thing up here. And we couldn't do this dragging before either. It's starting to like get better. So first of all, let's pull this one here and this one here, and this one does have something. Oh, so this is the TryHackMe rooms. The images. This is the one we just added, so that's correct. Sorry for cleaning stuff on stream, right? This one is the empty one. So let's delete this. Here we have buffer overflow. And then we have the others. Yeah, I'll just move this one here. It's renaming it. That's unfortunate. We'll have to do it manually. And delete this one. This is just normal files and folders. So the THM rooms one also has images. Oh my god, yeah, I did this because there were so many images. Yeah, a lot of images here. That's why. So let's actually move these in here like this. They're the way they are. Let's rename this one THM because this is a THM room. Just straight nothing else. Just like probably answers to questions and stuff. Didn't it move it? Oh, moving it to the wrong place. So THM. So we're getting back to the page soon. I'll just move a few more things. So this one's empty, nothing more here. Let's delete that. Let's actually first, I didn't look at the Atom directory, but it might have actually had something there. We didn't look in the Explorer for it. So it opened up over here. So let's just make sure there are no files in here, like Atom files or anything. Just MD files. And the images. So we can close this, we can delete this directory. And let's move the ones here out too. So, better organization here. Let's just quickly check this one too. I think it did, maybe, no? And delete it. So now we have the actual nodes we have on assembler and buffer overflow in the same place here. And this is 2 finished rooms and 1 that I didn't finish before, but I didn't want to spend time on copying and pasting all of the things instead of learning things, really, you know. So let's actually delete this one and its images, because it's kind of annoys me now that I did this. So we can just look at the web page. I guess that if I were to not have access anymore, because I stopped paying them, but we could still get the information somewhere else. And this, the reason I did this is simply that I could TTS these as a repetition, but it's not really worth it. And this room is not complete, so let's delete it. The other ones can stay for now. So I could just TTS a few rooms while I make food or something, right? For repetition after having finished the room. So that's the thought behind that. So now we're doing it more logically. We just put the things that are actually the facts, you know? We don't put stuff that are just them saying something in a way that I don't really like or something, right? So there's a few hints in there on what to do. Yeah, so maybe this is not useful even. I don't remember where this is from. I'm sorry for my bubbly tummy. Well, I was like, I'll never drink this energy drink again. What I should do is, and what's better is to actually move your body instead, right? It's 350. My. But that was like an hour of that was me biking and making food. So we can close this one. That's automatically opened at 10, probably. And this was the tip, and then we have the room. And this is the one we're currently doing. So let's add more notes in the notes when we find stuff that we think is worth being added. So this is previous stack frame for calc, return address, still part of the calc stack frame. So this is counted as part of that. stack frame for add. Stack top. Previous stack frame. Yeah. So I haven't forgotten that we were reading this too. So let's continue with this. Let's just quickly check if there was anything. So maybe this image is good. So my tummy is really annoying. Shouldn't mention it again, I guess. So, let's continue reading here. Store this. Store the contents of EDI into this. Into this. And then we do the move else, which is why we hopped off there, right? To check. No, not on that page. This one. The move else, how they work. I didn't I search for move? I guess I didn't. We found it before, right? I remember. So it's move L and what else? Difference between move and move L. So good enough. Copy this one. arg1. What? So we have ESI here. So first, if we just focus on the first one, store EDI in local 14 to EDX, and then we have EDX to ESI. So they're swapping places, that's why. It was like, this is odd. At this point, hold the values ready to be passed on to the add function. Okay, so this is why we had add function up here, so we could see what it did, because I don't remember that now. So int A, int B, int A, int B, they have the same order of the arguments and everything. A and B, the same order here too. They could have swapped them, you know. So why? It's ChatGPT, it doesn't have to be correct, so let's not dig more into that. Call queue. Yeah, I noticed all the F's here, right? Add. Call queue simadd, add the add function. This instruction does the following: pushes the return address onto the stack, jumps to the address simadd. So So how does this work here? I need to know the machine code better. I'm not pleased with this. So, please explain the machine code in. So why is it all FFFF? Let's break down the machine code. Understanding the call queue function. Calling near, absolute, relative, or indirect instruction used to call a function. Perform the following action. Push the return address. The address of the next instruction following the call queue is pushed onto the stack. This allows the functions to return to the car and jump to the target address. Instruction pointer is updated. Yeah, but I want to know what this means here. Offset, so it's an offset to the function's address, because I was like, this is an odd number. Okay, so 32-bit relative offset. This is what I was looking for. Yeah, and this is also called relative 32. So then it all makes sense. So call queue has versions: near, absolute, relative, and direct, and we're using the relative one, and that's E8 call rel32 with this relative address. Yes, now I got it. Let's get up to the back where we were. No, that's not where we were. Yeah, this is where, what is the whole thing? So, I think not. Was this the right place? I'm really sorry for my tummy. I'm really sorry. I should have a burp counter. I've heard people have that on stream. No drinking anything with bubbles in it. So, here's where I'm probably reading right. So, we did this. Here is it. Jumps to the address, and this is the then E8 is called relative. And we don't need to specify that here, do we? Because this will, the assembler, well, I guess it's just assembler, right? It will make this from that. And know what this is. Then it will use a relative. But it's really a compiler too, not just as an assembler. Because it doesn't have one meaning, right? Post function call. So, store the return value of add in EAX. So, now we have a minus here. These are also minus for the arguments. So then we have leave, which is actually right. So these So now we're getting to what I think is fun, right? Machine code x64. So can we just get a list of them all, right? I want it all. This is not a list. I want a list. Everybody's quiet. No one likes us. Is that it? Or are you focused? So let's not start with the differences or the details of operating systems. Nah, not a good one. Not a good link. So let's add reference, right? Notes on. So what are they making notes on? I guess I want the opcodes, right? I should say the opcodes. Nostalgic. So let's close both of these and add opcodes. We already have code, right? And I'm thinking like opcode could be one word. Ref x86.net. Now we might have something. Let's see. x86 opcode instruction reference. So what's this? Is it what we had? Yeah. We need to learn a bit more about different, what's an OP1 like, right? Instruction operands. Okay, so that's operands. Yeah, this is good. Opcode field is the O. So the O here, this one just says R. And this is a good list here. I'm in love. Yeah, so but I need the more information. So let's say that we want the one that we would do using here. We want C9 here. We want C9. So I can remember C9. We don't have to C9. So we have we're on number 3 of 11 matches. Alright, so of course we have them there too. So here is C9, leave. So it is this column here. So it was a bit empty at the start, you know? Was it? No, it wasn't. Yeah, so this is the one. That's what we're after. Then we can read all of these. This is magnificent. Let's just check at the bottom here. We have some tables again. So anyone else who thinks this is very fun? I know I'm crazy, I know. So this will have a place in our... So this is what I added for the vacation. So let's delete this. It just takes a lot of space. And this was... Oh, that was tabs I had opened. Let's move it over here. So these are the main links, right? So if we need to rate every stream, we have it first. Then we have other like main important sites, though I guess some of them are in the MAR because it doesn't fit, right? So do we have hack tricks? Don't they have? No, it's only here. So I thought we might have a double. Right, so
Panda Tongue says,
Johanna sent me a video of the cabin in Lake Saturday. Have you ever been up there? It looks amazing.
No. I don't think I've been that far north, you know. It's really far north. So, I don't really know how far I've been, but it was probably with my parents when I was like young. The furthest north I've been. Went like skiing when I was tiny. Like, before I could ski. When I was in the tummy and things. Oh,
I think it was almost the North Pole, lol.
Oh gosh. just a few meters from the North Pole. That's Sweden. No, but it could have been close to the line where it's always day or always night, depending on the season, right? What do you call that line? I don't remember. In Swedish either. I have no idea. I don't want to live that far north either. I want day and night. So I'm just listening for my kid. He went downstairs. Didn't want to go here. So this is information about this reference, and then I clicked this one, where we ended up. I guess what's this? So it's also here. ABC. What's ABC? Oh, so it's sorted on the... Maybe on this. So it's sorted ABC. We don't want that. We want the logical sort. What's Geek 64? What's the difference here?
I forwarded the video over to you if you want to see it.
Thanks. Yeah. Yeah, great. I'll look later. So I'm like, oh, I want to drink. Oh, right, I have this. Oh, right, I shouldn't drink this because my tongue will go even more bubbly. I should probably pour that out. Let's go for the water. That's a safe version. So why is this one different? And how is it different? So this, let's move this page over to start and compare these quickly. Let's skip that. So it's definitely different, but this one has more columns. Is that it? Or what? Yeah, I think this one is better and more readable, and this one has maybe too much information. So we know it's there if we need more stuff. And this one is the same, right? So we can remove this one. And these two are the same. So the base page of the site is this. Or rather, this is ref. Let's see what happens if we do remove ref. Welcome to x86 assessment. Focus mainly on x86 architecture, including x86-64 architecture, encodings, reverse code engineering, and system programming in Windows and Linux OS. Nice. So sometimes you find these pages, you know. UE5. So, projects. So I think this was a better page. I don't know how to get it really. Ref. There's no ref link here, right? Articles, links. So what if we click projects? Yeah, okay, so there we have it. So, general purpose library. FTPG assembler level debugger for user mode, binary application running in low mode 64-bit. So let's still use this one as the base page. And let's move it to here somewhere. So this name is kinda obvious. It's a good name. We don't always have good names for stuff, right? Should be happy. And there we have the thing. And if we need any other explanations, we just search here. So let's search for the one we did before, subq. So we get subq directly, and we get. This is not the one though. This is f subq. So let's actually look now on the opcodes in the room, right? Here. So this one has 48 for both these, move Q and sub Q. And I keep tabbing to nothing. So if we look at this number, or I shouldn't say 48, 48, right? So does it exist in this list? Does it? No, so I'm not Yeah, so the problem is what number is which to, right? So maybe that page wasn't as good as I hoped. Because I thought we would find all of those things there. We did find C9. Let's look at the C3 then, right? So C3. It's here. Return from procedure. And C9 we had there. Let's see if 5.5. So the mic is in the way, that's why I'm leaning. So there are several 5.5. Bitwidth, logical, and not of XML FF value. So this is not really the thing, right? What else can the F5.5 is it? It's in the tables. So this is only 5.5, which is logical. But apparently this is not like the right instruction. And they also need to know what this is that makes them 2. And let's go for and just confirm that it's not case sensitive search, right? And push Q didn't even exist here. Right, so we'll see if we use that thing. Let's see what else we found. This one that we already have opened properly, probably. This sheet, isn't it that? Sheet. Welcome in.
Fixerbot says,
New follower Jokersec. Less than 3.
Welcome in, Jokersec. So, yeah, we have these docs. I guess I want to read this on stream or people will die, right? My throat might die too. So let's use this to search for whatever it was that we were actually currently looking for. We wanted to see these. Yeah, so that's the problem. This one doesn't have the machine code. And I wanted to look at the machine code stuff. So, anyway, it's assembler stuff. That's... So leave this equivalent to restore stack pointer value to the frame pointer. Pop the old frame pointer from the stack. Return the function by popping the return address of the stack and jumping into it. So let's click so we get that selection of summary of execution flow. Now we don't need to read that. Yeah, and it was the machine code, as I thought. It only looks a bit odd. Yeah, right, it was the address that it was just a what did it call it? Well, just a offset anyway. So did we read all this? Yeah. Yeah, here. E8 opcode for call rel32. So relative offset of the function address. That's it. If I shake this a bit before, then it won't be so bubbly in my tummy, right? When I can drink it. So, yeah, so let's go back to the room. And I open that. This is a C code for that assembler. Once the function is finished executing, return. Red queue, this is return will pop the value of the return address of the stack and deallocate the stack frame. It's like deallocate isn't something you do, you just change the addresses. It sounds so funny when they call it deallocate. The stack frame for the add function change the instruction pointer to the value of the return address. So change the stack pointer RSP to the top of the stack and change the frame pointer. Yeah. So in the above example, we save that function. We save that function. Take arguments. The calc function takes 2 arguments up to 6. What function can be stored in these? Maybe we should add these to a list here. Arguments up to 6 arguments. It can be saved in registers. So RDI, RSI, RDX, RCX, R8, R9. And let's change this to an AND. So RX is a special register that stores return values of functions. Return values will be stored in RX. So I should have made probably more notes on this, but it's just that it doesn't have that much information. We had to dig a lot, right? Because I want all the things. If a function has any more arguments, this argument can be stored in function stack frame. More can be stored in the stack frame. So, can you now see that caller function may save values in the registers? What happens if a call E function also wants to save values in the registers? To ensure the value is not overridden, call E values first saved the value of the register on their stack frame. And I'm assuming then that they just push it there and use the register and then load the values back into the register. The caller function can also save values on the caller function frame to prevent the values from being overridden.
Lab Monkey says, finally catching you live. Love your content and you sharing your Obsidian notes. Saved me a lot of work. Sparkling heart.
Okay, thank you very much. That's great to hear. You're very welcome. live. So let's see. Yeah, Lab Monkey. Another great name. Thank you. So I will try to remember to update the notes. Kind of. We'll see. You can always tell me. Let's see. There. So I just put OBS on top so I can see where I'm at. So what was there anything special in the notes that was useful, or just generally? So to ensure values are not overridden, use the register and load the values back to the register. The caller function can also save values on the caller function frame. So the caller function saves function onto the caller function frame to prevent the values from being overridden. Right. Which is more logical, right? That you save it in your own rather than use the registers. Well, both, I guess. Here are some rules around which registers are called. Are caller and callee saved. Rules around which registers are caller and callee saved. Okay. So RAX is caller saved. I'm just comparing to the rest of the nodes. We don't have any nodes on RAX. Yeah. It's a return values. So that's why it has to be caller saved, because otherwise it can't be saved by the callee, because then it will be overridden by the return value anyway, right?
Lab Monkey says like to see how you using it in practice. Like adding code sections. And like you're being methodical with note taking.
Yeah, okay, thank you. So we're currently adding notes here to it. And I've moved the programming assembler to add some buffer overflow in info here on InfoSec, because this is the focus. This is where I'm building most of the notes. So let's continue. And these are caller saves, usually arguments for functions, yeah? R10, 11 are caller saved. We haven't heard anything about R10 or 11 yet, I think. And I'm thinking rules around it. This one has to.
Lab Monkey says, have you used tags before in Obsidian?
No, I don't really use tags, and I don't use that graphical view thingy. So, someone said it would make it easier to search, but I think it will make. We have a great search function in Obsidian, and adding a lot of tags would take a lot of time. That's what I'm thinking. But if I would get into the habit of doing it, maybe. So, do you think it's a useful feature that you use a lot? So RBX, R12, R13, R14 are callee save, and there we have RBX. Okay, RBP is also callee saved. Yeah, this is what I was thinking, that RBP is callee saved because it's can be optionally used as a frame pointer. It's a frame pointer thingy, and RSP is callee saved. So far, this is a more thorough example of the runtime stack. So I don't think this was a useful image at all, so we're not saving it. No, what is it called? So it was what restores the return address. So isn't that like, no. I'm like, what was it? Didn't say in here, did it? Maybe it said before. Yeah, so let's hop up. Not there. Oh, sorry. So I drank some Red Bull, and I'm not used to bubbles, so my tummy is going annoyed at me. So the stack pointer is RSP, the frame pointer is RBP, and I'm like, where in my brain is this? So let's actually look at one of the pages we looked at here. Also the the cheat sheets. So yeah, so they are also part of the themes, of course. I should know this like a million times. But it's not there in my memory. So let's learn more things. So now we're in operators. So it's good to just scroll through this document. So we have a jump, a conditional move, procedure call, coding practices. Okay, erase. Now we're getting complicated. I mean, for assembler, I haven't done that, I think. Maybe. Calling a function, right, we actually kinda want this, so
Lab Monkey says Rax?
possibly, but I need to know it and learn it. So I was just guessing there. So I think I just read it before today, but guessing is not a okay thing really, right? So that was all of that document. So this was a very like quick one to scroll through, I guess. Yeah, and here we have the GNU assembly uses old format instructions source destination. This is the different ones I was talking about. Source destination and destination source. It's like, why do they have different ones? So is there anything here? So this might be good here. So this is a general purpose register. So I'll read this. REX. And this is like the same register but just bits of it, right? Lower half in this. One of the other lists had more bits of them. This is a general purpose, but many people treat it as an accumulator, where the results of a calculation go. Yes, REX is also where return values are stored. Intel programming conventions call for return values to be placed in REX before returning, right? So this is a stack pointer, which points to the top element currently on the stack. The stack rows store smaller addresses, so a push operation decrements RSP. meaning it decreases when it increases. You can allocate local variables by decrementing RSP yourself, and pop the stack by incrementing RSP. And we had this allocation of, they called it allocation of memory there. This is a general purpose. Intel convention calls for the first argument for a function called to be passed in RDI. We will do this only when calling routines, but you should be careful about trashing this register.
NOTVICHU says, what are you doing in the stream, actually teaching hacking or learning by yourself?
So I'm mostly learning stuff, but if people ask questions and I know the answer, you're welcome. And I will learn more and more as I go. Hopefully be able to teach more and more. Also, I've worked in IT since 95, I think. And I've been programming since I was 12, something. So, if it's not exactly like about tools I don't know yet, I might have knowledge anyway. These threads are designed callee saved in the conventions. This means that if you're using them, you should save their prior values, restore those values when you're done with them. This is used for linking. Avoid using it. Number 11. So REX was the return value of a function. I'll have to read the question again because I don't think that's what they were asking for. Maybe they were, and you're right. So I'm looking for the instruction pointer's name. That's what I'm looking for. I'm just apparently. Maybe it's that I didn't read the question or that the question was not clear. But still, I wanna know things. Yeah, this is what I tried to type and it was wrong. So I had the right name, address of the next instruction, register or IP. So I had the right name of it. Confirmed there. I don't think capitalization work helps, it's not that. And there they do lowercase and they're uppercase.
NOTVICHU says, can you do a reaction on a song now? Named Big Dogs, it's trending, by the way, it's on YouTube. I'm 1000% sure you will be surprised.
No, thank you. I'll never do any reactions on anything. Especially on music and stuff. So let's hop back and reread the question, because so we have still not used this box. So it's been on for hours here, for 4 hours probably. So let's hop back here and see what register stores the return address. So let's throw this question here because we've sent a lot of information and see what it says, how it interprets it.
NOTVICHU says, please,
it says
kissing face.
Yeah, so the instruction pointer is updated on the target's address. This mechanism of call. Push the return to the stack's address. So it's on the stack. Maybe they still mean the stack pointer then, because that's where the old one is.
Lab Monkey says, what kind of subscription you have on HTB?
Nothing. I don't have any subscription on HTB. So I can't do boxes there on stream. I might get one when I'm completed more on TryHackMe, because there's no reason to pay for several things when you can't still do several things at the same time, right? So I'll probably get it later. Hi, welcome back.
Madam Fabulous says,
So
07.
I did try REP. If I undo now, it can't. So it's, let's see what it says. Is there? Does it say reply? Is stored on the stack, not on specific register. Yeah, but yeah, that's kind of the thing. So my RIP answer. Let's try it once more. Let's do capitals. See if it works. So this is a wrong answer.
NOTVICHU says, hey, do you know about laptops? I need to ask some question.
The only thing I know about BOF is they're tedious. D.
Buff. I'm like, what? Laptops. Yeah, sure. Ask me stuff if you want to. What register stores returners? I'll answer if I can, you know. We have a laptop that's currently called a desktop because it doesn't have any box anymore. So what register stores a return address? And we confounded this, and the answer, it's kind of saying the same answer I did. So I'm kind of thinking maybe it is RSP they're meaning, because it stores the address while we're not using it, right? But it's just a pointer to the stack where it's stored, so it's actually stored on the stack, but this is where it is? No? No, I'm open
Influx
to
says,
suggestions.
isn't the return address in racks?
Racks is supposed to have the return values of a function. So we can try racks too. So it's a bad question, but there's a bit of bad English in here. So yeah, someone suggested it before, so I said we'll try it. So this is not a correct question and answer. So racks is where the no return address is stored there, but the return value from a function is stored in REX. Right? If you just search here. So REX is a special register that stores the return values of functions. So it's definitely not like what I was thinking, the instructions, the return address. Well, so if anyone wanna tell them, I guess, what do you think? Are we done with
saves
this?
the address of the caller. Yeah, kinda confusing.
Yeah, it's not confusing, it's just wrong. In my mind. It's not it could be a return values address, but it doesn't say. That's probably English, not them not knowing English, you know? The one who made this room.
NOTVICHU says, yeah, I'm going to take a gaming laptop named Acer Algae 512th Gen with 16 GB RAM, 512 GB SSD, RTX 3056 GB for my study purpose and gaming stuff. Its price is $60K in India. In dollars it's about $713.
Okay. So I would never use 16 gigabytes for a gaming computer. You know, I'm having problems with 32. It's too little for my computer. But it all depends on, you know, it's still an odd combination. If you have a RTX 3050 and 16 gigs of RAM, they always do these crazy combinations. But you could probably upgrade the RAM if you want to. And also 512 gigs. Since it's a laptop, it's not like you're putting an extra hard drive there. And if you want to fit a lot of games in there, it could be a problem too. So, and those are just the basic specs. So we don't know about the rest. And it's an i5 too. It's not an i7. Well, it's probably much newer than mine, so it might be better than my i7 in this old thing. Probably.
NOTVICHU says yes, the RAM and storage is upgradable.
Yeah, but okay, if you can upgrade the RAM to at least 32. And the hard drive you could fit quite a few games if you're just playing games and not like having any other data like your photos or whatever on there, you know, or some videos or whatever. So that would probably be good. I think it's important that you have a good graphics card in a laptop if you're going to play games, and you have. So, right? I have a 1080. I don't know exactly how good 3050 is, but it's at least you know, kind of modern one. So let's go for the next one. Indianness. In the above programs, you can see that the binary information is represented in hexadecimal format. Different architectures actually represent the same hexadecimal number in different ways.
NOTVICHU says, ooh, 1080, it's a goated graphics card.
Yeah, but it doesn't have the new functions, you know. But it's still good. It's only very old. I have to look. So 1080, yeah. This could help. So 2016. So it's 8 years. So it's not really new, you know. That's kind of a long time. So this computer is probably like
Lab
8
Monkey
years
says
old.
you are so high tech. I'm still running a 970D.
Okay, yeah, but those are good too. Those are good too. Though my hubby, I think he has could it be 860 or 800 and higher number, whatever, or maybe 900 too. He can't run DaVinci Resolve anymore. It stopped supporting his graphics card. So there are drawbacks with older cards. Stuff are not supported.
NOTVICHU says, but everyone says a 1080 is better than a 3050.
Yeah, you know, 30 in there is kind of the family, right? How new it is. And the 50 is kind of like how good it is. So mine is an 80, so it's kind of high up, but it's old. That's an old family. So I have to do this too. Sorry, 1080 vs 3050, right? So it's an RTX thing there too. So here you can see you have a 91 here, and this has a 70. Or whatever number those are, I don't know. This is kind of
Lab Monkey
still
says, when I want a
expensive.
game, I will just hire a cloud PC. They are awesome these days and cheap.
Oh, okay, cool. Yeah, but you still need some stuff in your computer too, right? So, effective 3D speed. This one is better. What's this number? Okay, so it's like how good it is. So this is the 2080 is better than this, or is the next one. And that one's from 2022 and this one 2016. So, but let's not go crazy for these anymore, right? But here's like some kind of odd curve here. Well, you can Google yourself. So old is not always good because the support for the functionality, you know, it doesn't support the new like eye tracking, whatever tracking stuff, all of those things. There's much things I don't have that I want to have. So let's read this again from the start. So, endianness. In the above programs, you can see that the binary information is represented in hexadecimal format. Different architectures actually present the same hexadecimal number in different ways, and this is what's referred to endianness. Let's take the value 0x 1, 2, 3, 4, 5, 6, 7, 8 as an example. Here in the least significant value is the rightmost value, 78 or 78. It's hex. Well, the most significant value is 1, 2. Little endian. I'm kind of thinking they should put 0x there. Whatever. Little endian is where the values are ranged from the least significant byte to the most significant byte, and this is a messy, right? So it's like this. So it's 7, 8, 5, 6, 3, 4, 1, 2. Messy. And big endian is what's the values arranged the most significant, well, the normal way of a number, right? The normal way is to have this like 128. It's not like 8 is the most significant one. Right, we read this, and yeah, okay, so nothing more there. Overriding variables. Now that we've looked at all the background information, let's explore how the overflows actually work. If you take a look at the overflow 1 folder, you'll notice some C code with a... Alright, so now we're actually going to the machine here. Overflow 1 folder, you'll notice some C code with a binary program. Your goal is to change the value of the integer variable. So, can you see this? So, let's hop to the other machine. It's on the same side as the notes there. So, this fell asleep hours ago. So, let's see the overflow 1. And let's look in here. So we have an executable and the C code. So let's cat the int.c. This is bigger, right? So we have int main, volatile int variable 0, char buffer 14. So can you see in your head now how the assembler code will look like, kinda? Gets buffer if variable is not 0, and this is this editor's quirk. This is exclamation mark equals, and it writes it like this. I should change the font, maybe, right? Printf, if you have changed the value of the variable, else. Printf, try again. Right, okay, so we're supposed to overwrite this 14 buffer. So let's just run it and do it. And I'm like, was this really quicker? No, definitely not. Was it hard to just do /? So we know that we're supposed to input something. So let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then there will be a null for the string, I'm assuming. We'll see. So let's do that, right? You change the value of the variable. So let's run it again, and let's not do the right number. So we've 1, 2, 3. We get try again, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13. 11, 13. I did say it. 11, 12, 13, 14. We're just doing 14, right? So when we do 15, we get the overflow, and it changes the other variable. So we understand how this works, right, everybody? So let's read this now. This is just an image of the code. From the C code, you can see that the integer variable and character buffer have been allocated next to each other. Since memory is allocated in continuous byte, you can assume that the integer variable and the character buffer are allocated next to each other. Note, this may not always be the case. With how the compiler and stack are configured, when the variables are allocated, they would need to be aligned to particular size boundaries, e.g. 8 bytes, 16 bytes, to make it easier for memory allocation deallocation. So if a 12-byte array is allocated where the stack is aligned for 16 byte, this is what the memory would look like. So there would be padding here at the end. So we'll need to be aware of this too. The compiler would automatically add 4 bytes to ensure that the size of the variable align with the stack size. From the image of the stack above, we can assume that the stack frame for the main function looks like this. Saved registers, volatile int variable. Char buffer 0 to 13. So char RGB and int char C, which is the arguments. So this is finally an image that I want to put in my notes. So let's cut this. So we finally have an example that's worthy of the notes. What do you think? So let's put a line there and let's go more concrete, right? So no, yeah, it was just slow. So we have the image here, and let's copy the code too. So we have it over here. Oh, the include lines, I didn't see them. Of course they were there. So there, I should have shown you it like this first. So when we enter 14 up to 14 characters, well, I'm thinking it might be overridden with 13 too. Will it put a null at the end of the string? No. When we enter up to 14 characters, I have to test this, sorry. Let's see, we're already on that screen, so I'll just open this and let's run this one more time, and let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, and then we do let's do.
Lab Monkey says, what do you recommend in learning for security? C of Python? Or both?
Both, but I would start with Python nowadays if I would learn something. So that would be my first. And why do I have an odd? So what if I do just 0? Will this like do something here? Because you just put the text there probably. And that's 16 characters. Well, I'll have to play with that. Yeah, because I'm thinking the value will not be initialized, right? Or will it? Or what? Or yeah, it's checking if it's 0. That's what I thought. Yeah, it's setting it to 0. It's initialized to 0. It's setting it to 0. So if we were actually typing 0 there, which would be a null, which could be the end of the string. So if we type 13 characters, well, what did I say? If we type 14 characters, we will probably type 15 characters, right? With a null. But it will be a null, so if we set this to 1 instead and redo it, we might get another result. We need to do that. Let's see if they're going to compile stuff, otherwise we'll just play with it ourselves, right? I need to test. I need to know all the things. So, am I pleased with my notes? No, because I was in the middle of typing. And I couldn't answer this. Need to test using another value. Another value than 0. Suppose. So no. How do I make this? Okay. So font color equals red. So let's see if it works without me putting these about. Yeah, you don't need the string nuts. That's what we call them in Sweden. When we enter up to 14 characters, we get. Try again. If we enter 15, we get. So we get. You have. Will the string be null terminated? So I'm very curious. I'm sorry if this is not on topic. So there. Let's actually make it big again here. Now it's visible anyway. So we need to test this later, but first we'll look more. Even though the stack grows downwards, when data is copied, written into the buffer, it is copied from the lower to the higher addresses. Depending on how data is entered into the buffer, it means that it's possible to overwrite the integer variable. From your C code, you can easily see what the gets function is used to enter data into the buffer from standard input. The gets function is dangerous because it doesn't really have a length check. This will mean that you can enter more than 14 bytes of data, which would overwrite the integer variable. Try running the C program in this folder to overwrite the variables. We did. What's the minimum number of characters needed to overwrite the variable? Well, the answer might be 15, but we need to test that. So let's just check what they do in the next one, right? So we need to test it now because they're going on. Let's cat no. So let's actually use the notes because No. We can just do this. Yeah, it exists. Now I need to cheat because I didn't do this yesterday. So yeah, so cat procreation, that's what I was thinking of first, but we don't need, we can just test and run it to see if it's there. So these are stuff from my notes. I'm currently looking for, what is this? Yeah, so we could just you always the outfit file. That's probably enough. Here I have O for this one too, right? So so let's isolate this and let's actually nano the int overflow.c, and let's change this one to 1 and check if it is 1, right? So the logic is not changed, but the value is not the same. So we would see if it's null, right? So let's then gcc int overflow.c o int overflow 2, right? Okay, a warning, meaning it's dangerous and should not be used to. So let's see if we got a file. I think so. It was just a warning, it wasn't an error. So if we run this, and let's actually up a few steps and just add a 2 there. So now if we do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, what? 11, 12, 13, right? 14. You've changed the variable. Yeah, this is what I thought. So it's not actually, we need to type 15 characters. We need to type 14. So, I was right. So we're overwriting it before that, because it will null terminate the string. So, tested and done. So let's hop to the notes, and now we can sans the string is null terminated when we enter 14 characters. The int will be overridden to, okay, right? We tested this by changing. So let's just a parenthesis there. This is not important, by changing the init value and the test value to 1. And to really confirm this, we really need to do another test, right? So if we run this and do 3 letters, we get 3 again. So we didn't break the code, right? Right. So overriding function pointers. So I'll just go for a quick check of my kids before we continue, and very quick bathroom break. I'm curious what's the noise.
Veshihat says, we're doing buffer overflows. PogChamp.
So, yeah, we're doing buffer overflows. So in my path, there was another room that's buffer overflow prep. This one it is, right? So this is my path, but this doesn't start from 0, and it's not like really explaining anything, and it's horrible low resolution to stream also. So I'm thinking we'll do these other rooms on buffer overflow first. I'll just continue here. Overriding function pointers. For this example, we look at the overflow2 folder. Inside this folder, you'll notice the following C code. And let's hop to the box again. And typed in the wrong screen. So let's go to the 2. So let's get that one. Well, that's actually none of it, right? I think it has coloring.
There's a few challenges on buffer overflows on Picoct that are nice for learning concepts. Seems good.
Oh, nice. Thanks for the tip. So we can open. So I'm just googling buffer overflow. So we're getting a lot of write-ups. So this is my reminder to look at it later. Okay. There. Thanks. So we have void special. This is a special function. You did this, friend. Normal. This is a normal function. Other. Why is this here? Main.
Lab Monkey says, is it easy to run Picoct locally in Docker?
So I don't know. I haven't used it. So, but maybe the Shahid knows. So right. So we have an int, but this time it's a pointer. And then we have a char buffer, and then we have get buffer. and new pointer. So we're running this function that was set here. Yeah, so this one is not as clear to me. I get what we're supposed to overwrite. I don't know what we're supposed to overwrite it with. That's the thing. So let's see what they say. So time to learn
Pickup is a
more.
web-based platform. No need for Docker.
Yeah, I kind of thought so, but okay. Similar to the example above, data is read into a buffer using the gets function. But the variable, let's actually think here first. I was still thinking of this. So should I go to the site? No, let's do this first, because I think my kid's starting to want my attention too, so I want to continue. Similar to the example above, data is read into a buffer using the gets function, but the variable above is a buffer, is not a pointer. The variable above the buffer is not a pointer function in the last one. A pointer, like its name implies, used to point to a memory location, and in this case, the memory location is that of the normal function. The stack is laid out in a similar to the example above, but this time you have to find a way of invoking the special function. Yeah, maybe using the memory address of the function. Try invoking the special function. Keep in mind that the architecture of this machine is a little Indian. Oh my god, no, I don't know what to do. Let's look at the hint. I need the hint. Check the memory address of the function. That's what I don't need to do. I know that I need to do that. That was the worst hint ever. That's obvious to anyone who reads this, you know? But how to do it, that's what we need to learn. So let's just run it first, right? So we'll look at it. So I'm thinking we could add lines here. But that's not usually what you can do, you know. So we can run special programs. What's the program called that you run it like testing it? It's definitely in my notes in a few places. I'm searching in my memory. And I'm also checking in my notes where it could be. Right, so let's just run it first then. So, test. This is a normal function. So if we run it again and do something that overwrites it, it should be like mess, right?
Lab Monkey says, have you ever played Pony Island? You have to hack the game to advance in the game. It's funny.
Okay. No, I'm kind of thinking that I think this is fun. And this is more like learning, right? Yeah. So it will put a null at the end wherever that is also. So I'm just putting random something. Segmentation fault. Yeah. Because that's not anything reasonable. So we need we need to know the memory of it. So we need to run it in a special way to see it. And they didn't tell us, which is kind of annoying. This is
these kind of things annoys me, right? When all the information is not there. So just a sec, I just saw I got a message.
Is there a flag printing function in the C code?
On this one, it's just a basic. Just a sec. So just a sec. I'm just checking here. So I think my mom is feeling lonely. So just want to check that I didn't get any important messages. So let's see. Right, so I'm thinking let's do Linux running program. So we could start sharing instead of my notes, right? Let's do like debug. Let's see. No, that's not really it. Yes, stuff like strace, but I don't remember. There are several of them, right? So is strace what we want to do? Let's test strace, right? I don't remember the. So you must have prog args. Let's do H. I'll just want all of it to run, above the page. So strace, trace, just the program name and then stuff before and args after. Well, let's just run it with the name. Was it overflow? And right, it seems to need the dot, right? It's func pointer, that's why. Now I have to see if this helps. Just doing an F there, yeah. So I thought it had the same name. Strace func pointer. Let's see. Okay, so it found it but didn't find it. So now we have a lot of more information. So this is where we started it. There. Oh. So my hubby, he always calls when he's on his way back from work, driving his car, because he's kind of like bored or something, And now like, you don't have to call every day. So no, well, a reason not to. not that I mind talking to him, but he will be here soon, and then we can talk for real. I prefer talking to a person, you know, straight in front of me instead of when they're on the phone being bored. Because I will probably doing something, right? So, SXV, funk pointer, which is the name of the thing. 22 bar 0. So this is like, I'll have to understand how this works. Okay, so it's libc, so read 3. No, right. So I'm just reading this, and I'm like, this is what we need to learn, right? So let's just scroll down to the end. It was actually still on the same page here. So if we do 1, 2, 3 here, so then it will.
Diablo 4698 says, "Go for a bike ride."
I was already biking to and from work, so start the stream biking. Otherwise, maybe. I think there's a redeem for getting me to go on a run though. So, though it's a bit too late for that, because I need to go to my kids soon. Right, this is a normal function, this is a normal function. Exit group, exited. So what had really happened there? This is a normal function.
However, show me that the air in the bicycle tires changes.
No, I won't change it. I told you, if I get a flat tire, then I will change it. Otherwise, it will stay forever, you know? So, let's see here. So I did a short one, so we wouldn't overwrite anything. So if we do another one, which actually is bad, you know? So we do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then we do 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 should like get us a fault there, but also we should be able to like see the numbers. Trying to get this. By the way, let's actually, since this is new, we'll send this to ChatGPT, and it also, let's actually make a new one, because this one isn't the same area. So please explain. We could even knit code too. Let's raise 2 separate runs, the second string ending a segment segmentation fault. Explain the each what might be causing. So this just means that this program is executed, sets a program break to a new value, initially returns the current break. It just says break null and then 62,000. Though it's OX, it's hex. Open dynamic linker cache. fstat. So it will need to actually go deeper. This is not good enough. Retrieve the status of the open. Maps the cache file into memory. Closes the cache file. Open at. Sees on the library. Yeah, so I'm thinking this is not. Allocates memory. For the C library. Maps the C library. Is this a correct program to run, people? Is strace the right one? I know there are several trace programs. Maps a section of the C library read-write. It closes the C library file. Sets the thread TLS thread local storage area. Sets memory protection to read only. Sets memory protection to another range to read only. Sets memory for another range to read only. Unmaps cache file. Retrieves the status of SDN. That's a program break. It's a program break. That's a program break. Reads from SDN. Retrieves the status of SDN. Oh, I need to switch ears. Battery's going out. So, my throat is going out too. But I want to finish this if we can. So, the second word is similar until we read from SDN. Second word occurs due to the invalid memory address. This suggests a possible buffer overflow or misuse of pointer within the func pointer. When the input is processed, it may be exceeding a buffer's capacity to correct you. Yeah, this is correct. So fix this. You need to check the code. Yeah. The buffer is 14 cars. Is there a way to see the memory address code? So also I misspelled, not that it will care, but let's hop up to the code. No, I none of it, right? So let's actually cat it instead. That's why I like cat. We can just scroll up to it, you know? So the search button provided code suggests that the segmentation fault is likely due to buffer overflow. My god! Specifically gets function. Notorious for being unsafe. Enable 30 characters plus a null terminal overflow. We know. Here's the better for us to see the memory address. So they use GDP. Okay, so then we can get more information about it. Okay, let's do it. Hope it's there. So my throat is really kind of bad, and I have a bit of a headache too. So let's just check this. We want to do this carefully, you know. So we won't do this all today. Let's research a tiny bit more. Rather, let's just do what we were suggested here to test, right? But I think we could probably get this information several ways, right? So I'm just lazy here, so GB. So nothing yet. So it says that we should do break main, breakpoint 1 at, and then we do run, and it hits the breakpoint. Okay, so we do P buffer. So this is not what we want, right? So I think it's a bit messed up here. And new TR. So after entering the yeah, so we can do next. Step through the get call. Let's do next and see what it does. Next. Next. And let's do this one again. So it still says the same thing. The program is not being run. Yeah, so this is not a good thing. So let's just give it this. So I was just typing what it said, step by step here. Break main run. Starting program, breakpoint 1, P buffer, and this is what it thinks it would say, right? I wonder what these commands mean. We need to learn this. Program unexpectedly prints the message specialized in the normal, indicating as overridden. No, that's not the simple thing. let's see. I had the code in here. Now I have to double check. Wasn't I watching? Yeah, so we need to give it the correct address. Not just anything. So, observe the memory address buffer and the import is longer. So, it's fixing our code too. That was nice of it. The purpose is to learn buffer overflow. How buffer overflow works. I don't fix the code. The output. So, to observe the behavior of overflow and its impact on the memory, we can modify the way we approach debugging, ensuring that we have proper tools and symbols loaded. Below are the steps you can follow to achieve this. No. I want to assume we can't modify the executable or have access to the code. Yeah, so continue with GDP. Break main run info frame. Step through. So this looks more interesting. But I really need to stop too, because my throat is starting to kill me here. So... Okay, let's still help. Is this all the help? No, see? What do I quit then? Okay. Was it in the help? No. Funny. So, let's do it again. And let's do break main again, because that's what it's saying. And then it wants to do run again. And then it wants to do examine the stack to find the address of the buffer. So info frame. What I'm thinking is, didn't we in the main function create this? This is interesting, but so let's see. Then you want us to go step through the program to read the gets called. So I'm doing next, and no line number information, and we don't have a command line here, right? So let's still type info frame, because it doesn't say that, but I want to test it. And that was the input, so this is the normal function. So let's assume that we can do run again. Right. Start it from the beginning. And there's a breakpoint, so we stopped. And when I click next, it will run that. So can't I get more about this? I think there was more information. Step over, then get called to see the effect of the input. Step over. Why does it say over? Extra memory, around buffer, examine the memory, see how the input is. So this, I'll actually copy this, because I'm thinking maybe we'll continue this tomorrow. So this is cool. Here we can see the memory. So this was their example, right? So this is not okay. So this is memory close by. So still, this is hard to read for me. So if we're thinking the memory should be something like this, right? And it's backwards. So here it's 1. Here's the address. But where's the functions? So 7F, FF, FF, FF. So 1, 2, 3, 7. 1, 2, 3, 4, 5, 6, 7, and then it's E3, and this is E4. 9, 0. So I guess this is the function's address, but we need the other function's address. So let's just increase. So it's just saying print to see if it's been updated. I'm looking for the function. It didn't get what the point was. So what if we do 64 here instead, but just on one side? I'm thinking this changed what we see. So I need to know more about this command. Oh, why did I get that in copy? I wanted this. So please explain. The GDB command X 32 XP. 32. It's used to examine memory in the context of debugging. Here's a detailed explanation of what each part. So the X command in GDB is used to examine memory. So to examine allows you to view the contents of memory in a specific location. 32. This specifies the number of units to display. In this case, it tells GDB to display 32 bytes. Okay, so then let's just I need a clicker too. So if we leave this as 32 and then we just do like 64 here, we should get more memory, right? And we were like up at E4 instead of E3. So what if we do like a lot more? Let's first read what the rest of the command means. Specify the number of units to display. In this case, it does GDB to display 32 bytes of memory. X is a format in which the memory should be displayed. Here X stands for hexadecimal. You can see the memory content in hexadecimal location. B. This specifies the size of the memory units. The B stands for byte. So each unit of memory will be shown as a single byte. Okay. So, well, I guess that's okay. This is a GDB register variable represented as stack pointer SP. The stack pointer points to the current top of the stack. Minus 32 is an offset applied to the stack pointer. It means that we're currently looking at memory 32 bytes before the current position of stack pointer. So, we want the addresses of the other functions. To find the memories of other functions in the program without modifying the executable or having access to the source code, you can use GDB to inspect. I very much not love how it's repeating itself, right? Oh, I'm sorry, but I just almost said a bad word here. But right, we don't have to look at the memory. We can just skip this bit here. So, info functions. So I kind of like both of it, right? But still. So here's the special. So now we just have to convert this a bit, right? So it's still running. We haven't given it any input. So when we do next, we will be asked for the input. So I think special was the one, right? Oh my. Let's actually, the machine expired, but I'm still there. I'm still on it. Whatever. So that was like the sign that I should stop streaming because it's late, you know? So I need to do other stuff today. It's just funny that we're still running this. Since it's still in memory now, we're SSH'd into it. It didn't say like, oh. Right? Well, we'll see what happens. I was just going to look at the code here. So we are going to the special function. Normal is normal. Why is this here? So we're supposed to be able to test with other stuff if we want to. What I was going for now is to change this address here. I'm just copying it. So we have this, and what do we want to do with it? So we want to first of all make this into text. That's what we want to do. So from shortcode, and that doesn't work. We need to so what happened there? Change to raw bytes. So raw bytes. So what if I delete these? It still says raw bytes here. So even this is learning, you know. Let's say I wanted this to be. We definitely don't want raw bytes. Let's just stop that one. And let's see if we can just do it here, right? So we need to type it, that's why, in the input. We can't, I guess we can, maybe. So I think I can drag this to there. Well, what if we do ASCII? Did something else happen? What's decode and encode? I'm thinking this is the same as I just looked at, right? Here's ASCII. Okay. Was it encode I took? Encode txt. What was that? So let's actually split these and see if it gets some smartness out of this. I think it thought about something there. Well, thinking is not really a thing, right? So we really wanted to go from the number. So much easier to make this in a program, right? From hex. From hex. So let's 0x this again. From hex to ASCII. So do I still have this? From hexadecimal to test, convert. And let's also put these in the other order. And what happens if we remove the first two, right? Nothing. So, what if we copy this now? And we return to continue. Oh gosh, yeah, let's queue. Let's do next. And let's paste. And that failed. So that's kind of it for today. Because I need it closed down too, you know. So we don't really know what's what. That's still in SSH's memory, right? Some kind, maybe. Maybe is it correct? Is it not? We learned things. I learned things. I hope someone else learned something too. Thanks for being here. Let's rate someone. Let's rate someone who's online. So this is not really a stream. Black and Knock is Black and Knock. And then we have, so I rated the Black Hacker twice, I think, last week. Let's see what this dude's doing. So, Metasploit. And I gotta check. Anyway, we have to like have these up, right? Support each other.
Have 1 pixel up.
Oh, I'm sorry. I usually mute them. Yeah, she's doing the HTML stuff. Okay, so then we will go this way, right? So I might hop in there too. Or rather, I will. I shouldn't have closed it down. So, is it very quiet or is it that I have a very quiet sound? So, I'm just gonna copy this for Twitch. There, and then we're gonna copy this for YouTube. And then I'll continue tomorrow. So thank you very much for being here and everything. Thank you. And yeah. If you have any more fun things in this area to do, you're welcome to suggest it. And also join the Discord. And now we have a Discord link on both Twitch and YouTube. I just added it during the stream. So it's available on YouTube now too. You can just check in the section at the top, I guess, on YouTube, right? If you click the channel. Yeah. Thanks so much. See you tomorrow. Bye bye.